Okay, we're going to give it a little bit more time here. Welcome, everyone. We'll be streaming this event on YouTube as well and on Zoom. If you can, please join us on Zoom. But for those who cannot join us on Zoom, of course, join us on YouTube. All right. First of all, thanks everyone for joining today. This is our first storage provider virtual bootcamp organized by ESPA, which is our Enterprise Storage Provider Accelerator Program. As some of you know, we have started a first accelerated program, and as part of the outcome of that program, we are releasing a series of curriculum or training modules for those who could not join the accelerated program and are interested in becoming a storage provider in the Filecoin ecosystem. My name is Stefan. I work for Protocol Labs, and I'm responsible for growing the storage provider ecosystem. Today, I want to walk you through a quick agenda overview, what we're going to discuss. So first and foremost, we're going to talk a little bit more about our strategy as a whole, as a network. We'll have Juan himself present on the future of Filecoin and some of the amazing capabilities that are coming out in the next couple of months. We'll hear from our vendors, Seagate, AMD, and Supermicro, on their vision on the Filecoin and Web3 ecosystem. So very happy to see them participate, not only present, but they've been very actively engaged in our ecosystem. So we thought it would be worth for you to hear their vision and also how to engage with them. And then the second portion of today, because this is a 4-hour event, we'll be hearing more from our customers, why they use Filecoin, what kind of data sets they have stored on the network, and what are some of the key requirements when it comes to storing data into this environment. We'll hear from John Farmer, Chief Technology Officer, City of New York, Shadi, who's the CEO of Opshy. We'll hear from Arkady at Internet Archive, Sam Gustman, CTO at USC Showa Foundation, Jonathan Doughton, Executive Director of Starling Foundation, and then Alan Ransell, who will walk us through the Filecoin Grain project, which is a very important key pillar for Filecoin. And last but not least, I'll announce all the modules that will be made available for those who are ready to get started as a new storage provider in this ecosystem. All right, so let's go through a quick overview on what we're actually doing. We're not building just storage, but we're actually building the service providers of Web3, the future service providers of Web3. And so if you look at the landscape, right, look, going back to the 50s when hard drives were invented, storage has gone through a huge evolution. And so that evolution kind of includes, the transition from direct-to-touch storage all the way to decentralized storage today. And so that's where Filecoin comes in, where we see cloud, public cloud, which is the predominant storage architecture being deployed today, being replaced by a new technology called decentralized storage, which is where Filecoin is a perfect solution for that transition. So first and foremost, data is exploding over the next 5 years. I think it's no surprise. IDC, one of the major analysts, is forecasting 175 zettabytes of data that will be generated by 2025. So that's a 3x increase when you compare it to 2020. Of course, most of that information doesn't get stored because it's too expensive, or there's no technology today that can store this kind of capacity. And so, and also there's only so many bits that are being shipped by the major hardware vendors. If you look at today, the hard drive business itself is very consolidated. There's only like 2 major players, of course, in the market. And so, one is dependent on how much of these bits get stored or get shipped in the market that will actually, allow you to store data at an efficient cost. Second of this is that, the majority, 80% of that data is being generated by enterprises. So that's where, the major, the large capacities are coming from. And if you look at, where the data is stored, it's no surprise here either that it's primarily stored in public cloud. It's amazing how transition has happened from on-premises to public cloud in the last 15 years. And so 82% of all the data that's being stored is currently stored in public cloud. And so that's where, that's where sort of the bottlenecks are. We're starting to see some of the bottlenecks and some of the challenges. When you look at the existing service provider ecosystem, as cloud is very centralized and it's kind of managed by the main players, as we all know them, that are limiting pricing and data efficiency because you're basically using proprietary interfaces that are managed by these cloud providers. Second, as a service provider, you also get squeezed when it comes to margins, and it kind of inhibits innovation as well, as we have seen in the past. And so, there's a need for an open platform, a platform that can be used by anyone in the market that can just contribute storage and contribute to applications, and that's where Filecoin or our network comes in play. Second and third, storage is expensive because obviously when it's managed by these three major players or four major players, there's also more control there on the cost or on the price side. And it's not always verifiable and immutable, or it comes at a certain cost if you want that capability, where in Filecoin, those capabilities are inherently built into the stack. So there's a need for decentralized. Everyone has seen in the last 2-3 years, Web3 has exploded. Definitely in the last years, you look at the adoption of developers or the new developers that are coming in the space. It's amazing to see this exponential growth, and we'll continue to see more of that. Just with Filecoin alone, we have more than 600 projects at any given time being deployed on our network. We have thousands of developers that are actively developing against Filecoin, which is amazing. And so, if you just look at what happened last, or even this year, right, in the Super Bowl, there was 6 Web3 companies that were aired and during the commercials. More and more people are aware of blockchain. NFTs have grown tremendously and in value, but also in adoption. And it's our belief that eventually any digital asset that we create, whether it's a picture, a movie, or anything else that has digital value, will be stored as an NFT. And we're seeing that in different ways. Today, we're actually seeing this bridge between physical and digital as well, where digital NFTs are used as the key access to physical assets. There's a ton of examples out there, but in general, high adoption, high awareness. And so this is just a wave that's just starting. And then, of course, you see countries like El Salvador accepting new blockchains. And where we think the value is going to come in is not just in storing the data, but creating data DAOs that are decentralized autonomous organizations where communities rally around a group of data assets and really create, monetizing the value and have control over that value instead of having it controlled by some external central authority or third-party service that uses you as your product, essentially. So we talked about NFTs, has grown tremendously. I think we all are very aware of that. 2021 was we saw a huge increase in NFT adoption. And that's, again, it's not going to stop. It's going to continue. Today, we have Filecoin stores more than 40 million NFTs and growing really fast, exponentially, actually. So it's we're seeing a massive increase in NFTs. Okay, so now back to public clouds. We're seeing some challenges in public clouds. We're seeing service interruptions, closed interfaces, variable cost structures, essentially all the challenges that we've seen with existing cloud providers obviously will not stop. They will continue to exist. And so we need a solution that kind of breaks that apart and gives our customers, our storage providers, the service providers of Web3, the benefit and the ability to innovate. And so that's where Filecoin comes in. Filecoin is not just a decentralized network, it is a protocol that allows you to build multiple applications in the stack, on top of the stack, below the stack, and gives you a ton of flexibility. We'll hear more from Juan later after this session on what new functionality is coming out that is exciting and will open up a ton more new doors. But in general, Filecoin provides the economies of scale because today we have 15 exabytes of storage capacity across 40 different countries. We have a huge accessibility, meaning data can be accessed from anywhere in the network. We have data locality, meaning you have control over where the data gets stored. If you are, like for example, in Europe, and you have to comply with GDPR regulations, you can select your storage providers in, let's say, Belgium or France, wherever the data needs to be stored, and you can store multiple copies to ensure high durability. And last but not least, the cost is really cheap right now. It's almost free to store Filecoin. It's free with Filecoin Plus for sure. And it's less than $1 a TIB per day, 25 times cheaper than the cloud or even higher. So why should you join the community? So if you're a person that is not familiar with Filecoin, but you're interested, here are some reasons why you should join. First and foremost, one of our initiatives and our key vision statements is that we want to preserve humanity's most important data. As we mentioned, most of that data that's getting generated doesn't get stored for obvious reasons, cost or capabilities and technologies that are lacking of storing it. Second, you want to capitalize on the Web3 wave that's coming. And these NFTs, gaming, the metaverse, they're generating not just a lot of data, but also a lot of opportunities for new businesses. Third, you want to actively participate in an open network and get the economies of scale, get the access to a fully distributed, decentralized environment where you can benefit from the community, the power of the community. And fourth, receive incentives. So it's really hard to start a business. It's obviously not that easy. You have to raise funds. You have to have a differentiator. And so we will help you. And this is thanks to our beautiful incentive program, which are the block rewards to bootstrap your business. And we have some examples on what the ROI looks like if you step into that. And then fifth, take control back, meaning, as you as a service provider or a client that manages your own data sets, you want to be able to control how that data is stored, where it's stored, and how it's utilized and how it's monetized. And innovate and differentiate. That's always how you build a business, is to be able to differentiate whether it's on cost or new businesses that are being built on top of the platform, which you can do with our protocol. And then last but not least, if you bring your data to the network, you can actually earn passive income with your data sets. And I'll give you some examples of that. Sounds too good to be true. So first and foremost, the tokenomics model, for those who don't know, we have a block rewards system that's declining over time. And our system is built as such that the utility will eventually take over as the ecosystem grows, the network grows. As we can see, as we've seen in the last 18 months, the network has grown tremendously, much faster than we all expected, which is amazing. We have 3,900 and more storage providers and growing every single day. And so those rewards are there to incentivize and fund those businesses that are willing to step into this ecosystem and use that as a way to bootstrap their business as they bring in customers online, get themselves trained, build out their infrastructure, and then eventually can set a price for storing the data in the Filecoin network. And over time, utility, the pricing that you're setting will be taking over the rewards. So what about creating passive income? As I mentioned, if you have data, obviously we are very focused on storing humanity's data, but also enterprise data, etc. Our goal is to help you. And so we have an extra layer, an extra incentive layer built in here that those who bring data to the network today can actually apply for what we call Filecoin Plus. And Filecoin Plus is where you essentially get free storage assigned and a multiplier of 10x. A lot of details there, but in a nutshell, as a client, you get free storage. As a storage provider, you have an accelerate. You can earn 10 times more by storing that client's data. And it's just to incentivize a layer of trust that we've built between the client and the storage provider to incentivize those two ecosystems to work together and build better functionality and also build faster rewards or earn faster rewards to build their business. So if you have data today, let's say you're storing that, you're archiving that, why not bring it to the network and help you and create passive income that will help you fund your business? So it sounds very easy. Commit storage to the Filecoin network, you apply, and then you upload and bring that data to the network. So what does the return look like as a storage provider? Well, here's an example of a 1 petabyte, 1 PIB raw configuration where if you bring and fill it up for 500 TIBs, so 500, so it's half a petabyte, you file for Filecoin Plus data. Essentially, in 18 months, you can get an ROI of $120,000, even if the Filecoin price remains the same. So here's some projections on how that looks like. So basically, if you invest in 65,000 of CapEx of physical hardware, you pay for your monthly cost to operate your rack. Let's say it's 1.5K a month for 18 months, and you get a Filecoin loan. As you may not know, but you need a pledge. You need a Filecoin pledge as a support for Filecoin mining. So that total gives you 147,000 in investment. And after storing 500 TIBs of Filecoin Plus data, that gives you 120K profit after 18 months. Obviously, there's some projections as Filecoin goes up, that return will go up as well. And if you increase or if you add more Filecoin, or if you add more data to your system, that return will go up as well. So perfect example of how you can make passive income on your data set. Here's a second example for 5 PIBs of raw data with 2.5 PIBs of Filecoin Plus, which over 18 months can get you $600,000. Of course, the investment's a little bit higher, configuration is a little bit higher. We're talking about a full rack, sometimes 2 racks, depending on how you configure this configuration. But here you can make from 600,000 all the way up to 6 million. Obviously, all the assumptions, these are not guaranteed. These are based on an ROI calculator that we built that you can play around with yourself. So great returns, again, a perfect example of how you can build your business and at the same time store and protect your data on the network. Okay, so where do we go from here? So obviously we're not just a storage network anymore. We are building a ton of services on top of that. If you look at the ecosystem, a lot of startups are being built on top of Filecoin and take advantage of the verifiability of data, the immutability. And so all these capabilities that come naturally within the product itself are allowing all these new technologies to be built on top of Filecoin. On the other hand, we're also seeing the investment that you've funded basically with the Filecoin rewards can now also be used to offer different services. So you can use the GPU compute to do rendering services, or eventually also provide decentralized data center compute. There's a ton of decentralized compute solutions out there that could easily run on our stack. So here, what Juan will talk about a little bit more of the capabilities that we will build into the Filecoin network, such as smart contracts. And then eventually also, as we know today, we have our NFT.storage, our estuary interface. Those are all created to make the user experience with Filecoin easier, and so that you can upload specifically NFTs or large data sets into the Filecoin network. So we'll see, we're seeing a ton of development happening on top of Filecoin that includes CDNs, bridges to other blockchains or ISV ecosystems. We're seeing encryption technologies, RBAC solutions, then eventually a lot of dApps that are being built and eventually built as a service. All right, so this forms the foundation for a decentralized data center. That's why we are more than just a storage network. Now, how are we storing, or how are we providing support to our storage providers? Obviously, we want to help our storage providers through the whole funnel, through the journey. And so today, one of the key aspects or one of the key deliverables is to provide you with a virtual bootcamp. And so at the end of this 4-hour event, we'll share all these recordings that came out of the accelerated program that guide you through an architectural overview, the ROI, how to run and operate, what scripts, what tooling we recommend, et cetera. And then eventually also how to apply for a grant, how to engage with the community. All these things are very well described and presented in detail. But overall, we are here to help you. We're here, it's our goal to build the ecosystem together with you. All right, so one more thing I want to add. We also created a new training program for building more talent in the ecosystem. And so if you have any engineers or people you want to get trained, we have what is called a PL Launchpad, so please apply for that. It is a multi-week, 6-week program where we train people in the network and invite them to come join the Filecoin ecosystem. And then last but not least, as I mentioned, so what we are announcing today is a 20-hour plus virtual bootcamp. So you'll see more than 20 hours of recordings provided by experts in the storage provider ecosystem. So we have most of them on this call as well, but most of you will probably know them from some of the virtual presentations we have done. But very excited. This is not the last, this is our first one. And hopefully we'll, down the road, we'll update this with new content as we build new modules. So that was it for this session. But without further ado, I would like to hand over the stage to Juan, who will give us a quick overview on the future of Filecoin and some of the key and exciting features that are coming out this year. Let's see if Juan's on the call. Hey, Juan, welcome.
Yep, I'm here. Hey.
All right, thank you.
Cool, so I will share my screen. One moment.
And sorry for that. That is on my side.
Let me know if you can see the future of Filecoin slide.
Awesome, perfect.
Great. I'm gonna go full screen. Great. Excited to be here chatting with everybody. So I'm gonna go through a lot of different things in this talk. I'm gonna just first start off with a bit of an intro on why Web3 matters. I know many of you are probably not new to Web3, and so for you it'll be familiar. For many of you that are newer to Web3, some of this might be useful. Then I'll dive into some of the key components that are coming this year in the Filecoin network, and how those will plug into computational networks, and how those can plug into a whole host of layer twos that we expect to arrive sometime in the next year or two. And then maybe I'll sort of conclude with some look towards the future and different kinds of things that might be starting to build this year, but will take a little bit longer to ship out. Great. So it'll look. I'm going to cover a lot of stuff. So I'm going to, and I think we only have about 35 minutes, so I'll kind of move quickly through this. If you have questions, just post them in the chat, and I might use that to guide my conversation a little bit. I can't see everybody, so that's probably fine. I'll look at the chat though and see if there's questions there. Great. So starting quickly with why Web3 matters. The history of computing is a history of kind of waves and waves and waves of new technological improvements that come in to kind of build on the foundations of the last wave and enable and unlock a bunch of new capabilities and primitives that end up powering and next generation of applications and next generation platforms and so on. And overall, it's kind of leading to this hyperconnectivity in the world and so on. Web3 is the sort of next big shift in the computing platform. So the web is this large scale information and application platform that the world has built together. It's open and fairly decentralized in terms of who gets to create new components and connect them and so on. Although in kind of the Web 2 era, it got a bit hyper-centralized and a few kind of data monopolies and so on. Web 3 presents a whole new set of foundational primitives that use the powers of computing to kind of rewire how people end up forming a lot of these systems and so on. So in a way, I like to think about it as software is eating law and so on, and we'll look at it in a little bit more in a moment. So again, this is probably not unfamiliar to most people, and just kind of every generation of computing tends to change old assumptions and tends to create a massive amount of capabilities. We now have a hyper-connected society and a hyper-connected set of economies where billions of humans are interacting together, with most of our activity and most of our interactions going over the pipes of the internet. and mediated in some way or another by internet protocols, by internet applications, and so on. And so that means, by the way, that the properties of the underlying platforms are extremely important. So if the platforms start falling apart or deny access to certain groups or things like that, that creates an extremely brittle foundation. So this is one of the key thrusts of Web3 is to try and establish a radically more robust computing platform. And of course, the story of the web has been this phenomenally kind of equalizing force where anybody can dream up new superpowers and easily program them, build them, deploy them out to the world, and anybody can now use them and so on. Of course, not everybody. There's still a lot of connectivity problems to solve. A lot of there's billions of people still without good access to the internet, either no access at all or access in very limited networks and so on, or flaky networks and so on. But that, over the next decade or two, of course, a lot of that will improve. Either way, though, one of the really great benefits of this entire platform is the ease and ability for anybody to write new systems, deploy them out into the world, and so on. Now, one of the fundamental flaws here is the computing platforms that run everything today are again tied to these massive data monopolies, and they present failure modes where if you can attack the data monopoly in some way or whatever, you can gain control over who gets to drive what information and whatnot. So kind of like where we're headed with Web3 is kind of like a radically more robust platform that can put into place the sort of systems to enable drastically more decentralized and robust layers that anybody can help serve and help provide. And at the same time, anybody can use to distribute their applications and systems and whatnot, and where the kind of the rules and the rights for who gets to use the application or the system and so on are very well specified and very well defined. So it sort of creates this read-write trust world based on cryptographic primitives like public verifiability, incentive structures, mechanism design, and so on. So think of the kind of fields of game theory and fields of economics and so on getting infused with computer science, and then using that to form foundational primitives upon which we can build computing platforms. There's all kinds of like different important values that are part of the Web3 movement and so on. Each of these things tend to translate to different kinds of systems and different kinds of structures and different kind of platforms. At the end of the day, it's software eating mechanism design. So that means that everything from currencies to contracts to financial instruments to organizational primitives and so on, all of that can get now represented in software, changed in some way and whatnot, which is leading to many different new kinds of structures. My favorite graph, and you probably have seen Web3 in the world, kind of just consuming all different kinds of industries, changing the nature of how people build applications and across a lot of these different industry verticals. But my favorite graph in the entire space is the hash rate of Bitcoin. And it's kind of an old graph. It's one of the very first important contributions of the Web3 space and whatnot. But what this shows is like the tremendous power of incentive structures. If you deploy an easy to use system where any participant can provide some service, can provide some useful capability, some kind of service to the network, and you enable them to just join the network and participate, it can summon out of the broad reaches of the internet massive amounts of computing resources to be aligned towards a goal. Now, the difficulty is in how to make it really easy for people to participate, how to align that participation to create like really useful components and so on. But this kind of shows how powerful these kinds of incentive structures and these networks can be. It's really amazing just in the short time that the Filecoin network has been live since the mainnet launch. Amassing in the order of 15 exabytes of capacity is an enormous feat. Many large companies, many large groups took many years or better parts of a decade or beyond a decade to get remotely close to those systems. I've been talking to many different kind of storage companies over the years, and I remember like one company was like super proud of like the massive achievement of getting to 50 petabytes of capacity, and like that's a big deal. But this is kind of shows the level of power that amassing this kind of resources can mean. Now the the important part is how you then orient and organize all of these resources to provide really valuable contributions. One important note here is like it would be great to see a lot more storage providers in South America, in Africa, and in Australia, and so on. Of course, all over the world needs to grow, but if you look at the distribution here on the map, you can see some like big gaps there. So those are like really great areas to go and help provide services. Part of what will help here is, and we'll talk a little bit more about this in a few minutes, but part of what will help here is mechanisms and incentive structures for being able to move data to specific regions, provide them in specific regions, provide retrievability in those specific regions, and so on, because that's part of like the useful service of a platform like this, where the data is located, how the data is served, with what latencies, and so on. All of those are like really critical characteristics, and creating good mechanisms for that kind of stuff can help broadly diffuse the computing platform. So this is kind of like an interesting calculation of just how much storage, what kind of data we could store on a network like this, and this is super fantastic that we can now store vast amounts of the world's valuable data, and that's what a lot of us are focused on right now is kind of improving the tooling and improving the systems to make it drastically easier to just load petabytes and petabytes of really valuable, useful data to the network. I'll make a brief mention about IPFS because a key component of the Filecoin network and how Filecoin works and so on. IPFS is a network protocol to make the web operate in a peer-to-peer fashion. This means being able to link information together through cryptographic hashes and being able to refer to large data sets or applications themselves, like web apps or even mobile apps, all by cryptographic hash. That's a really important set of primitives that enable a lot of different useful applications to leverage the kind of content integrity and authenticated data structures that this gives us. We've only just begun to tap into the utility of this. This works even through network partitions, and that's not a common thing within the blockchain space, but imagine being able to kind of do software distributions of programs or like kind of supply chain things, or even kind of video, or kind of like all the app stores need really certified, authenticated distribution of software and whatnot, and then all that needs to work through network partitions and all that kind of stuff. So expect the Filecoin network to be able to leverage all of this utility kind of in the coming couple years. So the mission of Filecoin is to build a decentralized, efficient, and robust foundation for humanity's information. We are well on our way to that. We now have, as we saw in one of the previous slides, the capacity to now support collecting and gathering, replicating, and backing up vast quantities of humanity's critical information. We're on the path to bringing a lot of that data online. A lot of the community is sort of starting with large-scale data sets that are either public in nature, and so they're kind of of public interest, or where, for example, cost is the dominant factor in the storage of that data, because as a lot of the tooling gets built out, it'll take time to match the quality of the UX that people expect from a lot of the storage networks. So it's way easier to start with very large data sets that are kind of public in nature. However, I've already seen a number of applications and storage clients that are starting to use it for a lot of private data and so on. Right now, the interface is a little bit more rougher for those users. And those users have to kind of do some amount of the encryption and access control stuff by themselves, but they can use a lot of like standard software libraries from the web and so on. But expect that as all of those kind of interfaces and tooling syncs into the software libraries for Filecoin, to then just broaden the utility to a lot more applications and a lot more users. One important key piece here is the efficient part, which is to really build a robust and efficient market that can leverage participation from users around the world, wherever they have access to super cost-effective resources like energy or hardware, or they're like really well placed in specific locations of the internet to be able to serve data from like the right spots. The retrieval markets, I'll talk a little bit more about that in a moment, but the retrieval market is going to be a really key part of this to be able to kind of serve data efficiently from various points. One thing to keep in mind when thinking about Filecoin is that it is a large-scale project with a lot of parts to it. So as you get deeper and deeper into the network and how it works and so on, you'll see many different paths. And depending on your interest and depending on your organization and what you care about, you might sort of like focus only on a small part of it, and kind of like really kind of develop expertise in that area and be able to kind of participate in the network in that range. But it is a super large scale effort with lots of different parts to it. So there's parts of this which is building a layer 1 blockchain and making that work, and have a consensus powered by useful storage, which is one of the really key components. There's parts of this in terms of creating a proper decentralized marketplace in which to kind of offer storage and offer retrievals and so on, and potentially later other kinds of components like I sort of expect that once FEM arrives, all kinds of really interesting storage contracts will appear that can embed into those storage contracts many different features like programmable conditions by how the storage is supposed to work and so on. And then think of providing all of the kind of SLAs that a standard storage cloud needs to provide, and achieving that out of a decentralized network. So that means many different participants will be focused on achieving certain kinds of outcomes there. It could go on for a while, but think of the standard application platforms and being able to distribute and any kind of end user data from standard documents and data storage or object storage and so on, but all the way to running entire application platforms and being able to even do the entire distribution of the software itself, or hosting all the data for those applications and whatnot. Once Filecoin becomes highly partition tolerant to be able to kind of operate in long periods of time and in kind of disconnects and so on, that'll become extremely useful, because at that point you'll be able to use it for mission critical applications in ways that today you can't use most storage clouds for them. Cool. So the community is huge. There's a lot of participants around the world. Again, depending on which area you care most about, keep an eye out for lots of different events this year and next year. Now the world's sort of opening back up. I now have heard of at least 10 or 15 different Filecoin events coming up in the next few months in this year. And so they'll have, of course, different focuses and whatnot, but you can learn a lot more about what's going on in different parts and so on. One important thing to consider when thinking about Filecoin in the context of Web3 and the next wave of application platforms is that most groups are focused on increasing the transactional throughput of existing layer 1s or providing some new interesting primitives within the programming languages. We're the only ones focused on really enabling a storage network with exabytes of storage capacity. And so and we're focused on building a lot of bridges to all of the other networks to support the use of data in their applications. So already tons of applications across these other networks store their data with Filecoin and access their sort of store application data, store information, whatnot. And once the FEM arrives and we have the ability to construct proofs about programs being run correctly and so on, that'll make Filecoin and the use of Filecoin dramatically more useful to all of these other networks. And so we're trying to sort of align Filecoin with the success of Web3 in general, where success in any one of these other networks can also translate into success for Filecoin. So great, let's talk about this year a little bit. And I won't dive into this with this as an example of kind of what happened in just 1 year of the network. This is kind of like a snapshot taken kind of 1 year after mainnet liftoff. Massive amounts of, the storage scaled enormously. Many software improvements arrived into the network. The chain operated many times, which is kind of faster than many other blockchains, and so on. Many different kind of capabilities and systems came online and whatnot. Lots of different developer on-ramps were built. Tons of developers and contributors came to the network, and so on. It's kind of like another view at the same sort of thing. Massive scale in storage, lots of new storage providers, tons of data added, and so on. One word about the developer on-ramps. These are key key services that enable a lot of application developers to kind of find a tool that's designed for their use case, and kind of solves a lot of the problems of how to use decentralized storage and whatnot for them. And so this has become a very successful component. We're kind of like onboarding and storing with things like NFCO storage and Web3 storage and S3 and so on becomes a really key component in some application developer's pathway to being able to use a lot of the tech. Because again, like the use case differences, storing an NFT long term, or storing a video long term, or storing a petabyte of archival data, all of these look pretty different, and so you end up needing very different software tools tuned for your use case. And so the set of like developer on-ramps that are being built now are super useful, and that's an opportunity for a lot of groups, right? So there's only a few developer on-ramps so far. There are many more that are being built now, and more that are likely still need to be built. So that's an opportunity for many application developers that can solve like some interesting problems there, tune a product to a specific use case and whatnot. One important achievement of the network, and Stefan talked a little bit about it, is this builder funnel. This is a super useful resource for a lot of builders out there, because you can get access to a lot of resources and knowledge and people to help start help people start applications and whatnot. So if this is of interest, definitely reach out. Skip through these parts. Sorry, I was giving a bit of an overview of 2021, but I'll move to 2022. So this is a snapshot of a lot of the different efforts in the roadmap. It's probably too little for most people to see, but you can access it online. You can take a look. There's a lot of different efforts that are going on across the network. I'm going to focus my conversation on a few areas. So the computational side of things, so FVM and the programmable primitives that are going to arrive through that, and the compute over data side of things. That part is I think where a ton of the utility that I think no blockchain platform can enable right now is going to come out, and I think that's a super promising area. So one thing that a lot of people are doing now is kind of helping a lot of SPs globally grow. So accelerator programs, boot camps, and so on, and kind of access to capital. That kind of activities look super useful. There's a lot of efforts going on this year on scaling Fatman Plus. This is the program to enable a lot of like really useful data to come online. And this kind of like is a way to kind of make it economically cheap for clients to onboard vast amounts of data onto the network. There's a lot of efforts in these developer on-ramps. So again, things like NFT storage are exploding. Like we've seen this massive growth since the beginning of this service, just an enormous amount of usage. And so, I'm expecting kind of like video.storage and so on, and if other developer on-ramps to appear like that, that will, again, find sort of product market fit with a specific use case, and then explode like in terms of leveraging the utility of the network. There's one big improvement that just landed yesterday, which is snap deals, being able to use dramatically decrease the cost of making capacity sectors useful, to be able to kind of easily and much more cheaply make use of all of the capacity that people have enabled. So that went live yesterday, and that's super exciting. There's a whole range of activity that's going to come from the retrieval markets, and so there's a lot of different efforts along this. Maybe what I'll say here is what we want to end up with is solving the CDN problem, which is how do you provide extremely low latency retrieval for a subset of the critical hot data that you want to deliver out into the most of the world. And there's a number of projects working on this. Strong highlights to Mael and a few other groups that are shown here that have been writing a ton of the software components over pieces to enable this to come online. I've been spending a lot of time on this problem over the last few weeks. It's super exciting to see what's about to come online. I would expect that probably in the next 3 to 6 months to be able to now start serving petabytes of data through these networks with kind of very low latency with nodes around the world. This is one of the things that's been highly requested by the whole community, because today kind of becoming a service provider is difficult. And so people need a much easier sort of on-ramp into the network. And so being able to join as a retrieval market as a retrieval provider, dedicate a little bit of resources, get your feet wet with the network, learn about Filecoin and so on, and then use that as an on-ramp into becoming a storage provider. That'll probably help. I think you guys are all too early for that, or too early to take advantage of that, or this is going to come later. But potentially, as you start building out your facilities and so on, keep it in your back of your mind that this kind of stuff is going to start arriving in the next few months, and so this might become extremely useful if you have like access to some specific colo facilities in areas of the world where there's a lot of kind of downstream users that could, where like the CDN use case can become like really valuable. The retrieval market might be interesting for you. There's another component here, which is there's a whole project called Filecoin Green, which is about decarbonizing Filecoin. And so that means getting to, we want the Filecoin network to be not only carbon neutral, but ideally carbon negative. So we want usage of Filecoin in a specific region of the world or in a specific nation and so on to mean just net positive environmental impact. There's a lot of work to get there. This is kind of a long-term project, but already we can do things like estimate the level of energy use of the network, tie that to renewable energy credits, and a whole other set of like really useful kind of incentive structures that enable kind of this to become the greenest storage platform. We'll get there over time and follow along with this project if that's interesting to you. All right. Now I'm gonna slow it out for this part because the FVM is probably the thing that most people kind of want to know about. So the FVM is gonna bring in the power of smart contracts to Filecoin. So this is one of the things that we wanted to launch the network without user smart contracts at the beginning because it had already a massive amount of features and complexity and so on. And so we wanted to stabilize that first before we added the ability to kind of bring arbitrary computation into the network. That's arriving this year, and the way that it's arriving is with a pretty awesome novel VM that blends WASM. So WASM is kind of like the core computational runtime that Filecoin nodes are going to enable, and we use WASM embedded with kind of like IPLD, which is a component from the IPFS project to enable hash-linked computation and hash-linked programmability. So that means that you can distribute any kind of program that you may want to that you can express as a WASM target. You'll be able to kind of run through that kind of like lower part of the VM, and then on top of that part, we then bring in all of the standard blockchain primitives in terms of what we call actors and other groups call smart contracts and so on, and accounts and so on. Now the FVM is built with a layer of sort of compatibility. It is meant to be kind of like a hypervisor underneath other runtimes. So you can bring in the entire EVM runtime and have full EVM compatibility right away. And so be able to use all of the smart contracts that people are developing for Ethereum. And you can think of also other smart contract runtimes like Agoric and Solana and so on being added as well. So that if people and groups are used to building in some other chain and some other system and whatnot, they can very easily build bridges to being able to Filecoin and be able to tap into the capabilities and utility of the Filecoin network. And so that's a really important component here, which is we want to make Filecoin super useful to all of the groups building across Web3, independent of chain. And so you'll be right away in the first few weeks and months, people will be able to write Rust-based actors, and then the EVM compatibility will arrive right after, and then later on some other foreign runtimes will be added. So this is kind of like a zoomed-in view into that. And one of the things that we're targeting and factoring into this is that we want to make it super easy to do cross-chain computation. So a lot of the people in the blockchain space shy away from this because it's complicated and hard. But we think that at the end of the day, there'll be a multi-chain environment with lots of programs and lots of systems calling each other through many different blockchains. And so we want to enable kind of the distributed computation primitives to just get better and get easier to work with, so that you can build large-scale Web2 scale systems. And then there's an FVM website that kind of goes into the progress of the project and kind of where the different milestones are set to launch. It has like a little component there where you can play around with the different use cases. I'll mention a few here. So one of them is kind of the one that I'm most excited about is decentralized computation. So being able to use the FVM to add kind of like a task scheduler to Filecoin to then be able to issue distributed computation to run over the data that's stored. So imagine now being able to upload your data to Filecoin, hire participants to store your data, and then be able to then run jobs against the data wherever it's stored. So it's dramatically easier and cheaper to move the computation to wherever it's being stored, run it there, and then take the outputs and store them back into Filecoin or retrieve them or send them somewhere else and whatnot. This is also will be a really useful source of revenue for storage providers because that means the storage providers can be paid for storing the data and for running the computation. So think of all the GPUs that people have as part of the doing the sealing process and all that kind of stuff. People will be able to leverage those extra CPUs and GPUs to then run a lot of computation for users. We're specifically targeting things like enabling large-scale data analysis pipelines. So think of like being able to run machine learning jobs and so on over this. It'll take a while until this can fully compete with like the super sophisticated, dedicated platforms out there. But it'll likely be able to compete on cost right away. So for groups that groups that are doing large-scale computation and they can kind of afford to play around with networks that are newer and systems that are newer and early on and so on, those groups can probably get like a massive cost reduction that might kind of bring over a lot of users. So again, decentralized computation is going to be super exciting. One of the primitives that you get out of this too is that you can do certain kinds of decentralized certain kinds of computation that today are not at all done in the traditional computing clouds, which is you can do provable computation. So that means you'll be able to issue a job and then as part of that job produce a cryptographic proof that the job was done correctly and according to certain specifications. And that proof can become a super useful component and added kind of component of value. Other things like that, another kind of blending of really useful cryptographic primitives that enable new use cases include things like fully homomorphic encryption and so on. Like those kinds of cryptographic primitives are around the corner. They're going to enable a lot of super useful, vastly more powerful computational platforms. And we expect that we'll probably have one of the first networks that can do that kind of computation. So it'll be stay tuned. There's a lot of super exciting stuff on this. There's a lot of other applications and use cases that the FVM will enable. So think of like being able to blend the successive DAOs to create a thing we are calling data DAOs, where the DAO forms the basis of a community and a group of people that are aligned in preserving some critical data set. So think of people that are working in museums or galleries or some kind of important archive, being able to band together, be associated with a specific data set that they're trying to find, collect, curate, preserve, and long-term govern. And so think of being able to kind of have the sort of like human organizations of people and groups interested in the preservation of critical data and the use of that data as being kind of be able to be supported by smart contracts running on Filecoin. Quick plug for Jonathan Doden, who, if he hasn't spoken about this in this bootcamp or will later, definitely pay attention to what he's been working on because it's super fascinating. This it's a lot of like really important kind of primitives that are going to enable groups of people to organize and support kind of long-term maintenance of data this way. There's other things that I mentioned here, and then kind of speed up because I think I probably am close to being done with my time. So the other part is once the FVM arrives, that'll enable a lot of layer 2 systems to be hooked into Filecoin. This can include things like incentivized DHCs and incentivized content routing systems, the retrieval networks that I described, and so on. And on top of like all the traditional layer 2 systems that are working on things like Ethereum and so on and others. So think of like all the ZK rollups and so on, like all that kind of second layer computation will be enabled here. This can also mean different storage markets and different storage contracts. I think listed here as sort of perpetual storage and so on, but think of being able to have smart contracts that can govern the decision making around when to renew certain deals and for how much and where to replicate or how to repair data and so on. Being able to imbue being able to create a mechanism that is going to run on your behalf, some kind of agent that decides how and where to store the data and whatnot, who to make deals with and so on. The FEM is going to enable that kind of application, and this might also enable kind of like this is sort of been proposed as like space-time futures, where you can kind of reason about the storage in the network for a specific point in time in the future and start building markets around that. So think of being able to have the financial infrastructure to then really turn cloud storage into kind of like a sophisticated marketplace in a way that I think has never really been done before. And so there's a lot of kind of Web3 primitives and Web3 power that is going to come out of that. And then think of a ton of other kind of facilities for the storage providers themselves running a service. So things like insurance contracts and staking protocols and capital formation and so on. Like all those kinds of primitives and components can be supported and assisted by smart contracts directly in the chain in the same way that things like Ethereum and other systems have enabled. So I think there's a ton of possibilities and capabilities that are going to kind of suddenly arrive. If what I'm describing now is interesting or kind of excited to follow along or have an idea for something, I recommend applying for the FEM Foundry. This is a group that a group of folks who are going to get a lot of the early view into both the code and kind of like help and support from the engineers building a lot of the FEM components, so that if you want to launch something with the launch of the FEM, you can start working on that sooner and so on. Fair warning, like a lot of that stuff is going to be earlier. You're going to have much earlier access to a lot of the tooling and so on. So the SDKs are not going to be as nice as they will be later on. But if kind of time is really important for you and you want to kind of launch something sooner, definitely check that out. There's a ton of applications already. So I would imagine like not everyone will likely get in and so on, but over time, yeah, keep an eye out for what's going to be arriving and so on. And yeah, for service providers, probably the highest utility will be things like layer 2 networks and decentralized computation networks that enable you to run a lot of different kinds of systems around the data, right? So think of a model where you are helping not only keep around the data and save it and store it long term, but also run a lot of computation around it. And here's a snapshot of like the kind of thing that could enable. So think of going towards computational clouds like EC2 and Amazon Lambda and Cloudflare Workers and so on. Yeah, so it's sort of expected in the future we'll have like this very successful kind of service provider setup where you have both the storage and the computational side of things. Some of the other things that we're working on this year and include kind of scaling the chain state and scaling the computation. So this means really shooting for the kind of network that can support traditional Web 2 scale uses. Today, most blockchains can't remotely get close to this. This will take longer than 2022. This is more of like a 2023 type of project, but a lot of the components and primitives are being built out now. We are shooting for something that can deal with billions of transactions per second and that can have local finality. In the blockchain space, this is like seen as like impossible or close to impossible. However, Web 2 systems do it. There are ways to achieve this in the Web 3 way. Stay tuned for that kind of facilities. And something to pay attention to as well is, I think NFTs are controversial for a lot of reasons and so on, but what they do enable is like this fantastic creator community that enables a lot of participants to generate many different kinds of media and art and so on. Really pay attention to this movement because it's really, really massive. And there's a lot of misinformation going around about it. But what I will say is like, I've never seen creators so aligned with kind of like platforms this way, meaning like the ton of creators around now have control and mastery over their data and over their content and over how their art is being created and used and so on. And this is gonna see the beginnings of different kind of like video production and game production and so on. And kind of it starts with a distribution platform. So for us, what that means is that if we can make Filecoin the kind of best way for people to have to be able to preserve long-term artifacts that represent either a 2D art piece or a 3D art piece, or a metaverse room or a full-length video or full-length film, that becomes a whole new set of use cases and communities that can leverage the content. So yeah, pay attention to all this. A lot of amazing projects that have started just in the last year and are already kind of scaling super fast. So a lot of really amazing stuff, and that's kind of what's driving a lot of that NFT storage growth that I showed. All of those components are going to seed the world with the components that we need for building the metaverse. So I think the boundary between a game and the metaverse is going to be kind of like the rights and structures that you can enable with Web3. And so a lot of the components and people building 3D rooms and people building experiences and games and whatnot, we're going to see expect that we'll see kind of a super open metaverse built out of a lot of these components and primitives. And we aim for Filecoin to be the #1 storage network that everybody uses to really build out the experiences of the computing experiences of the future. Cool. So I think probably have run way over, so I'm gonna stop now. Thank you very much. I saw a few questions that I tried to kind of address en route, but if I'll leave it up to others to let me know whether to stop and go to the next person, or whether I should answer some questions.
It's great, Juan. I think we have some time, like maybe 5 minutes, to address some of the outstanding questions, if you don't mind. Let's see. I honestly, I dropped out, so unfortunately I don't have the full history of all the questions. So maybe if you could,
yeah, I can
run through it,
through.
that'd be awesome.
Yep.
Thank you.
See, I think some of them are getting answered along the way. Let's see. So yeah, maybe I'll start kind of from the bottom up. So who's working on a Web3 Dropbox DAO? So there's a few groups working on kind of software tools who have like a Dropbox-like experience. The two that I've seen like that are most complete and high quality and you can use today are chain-safe files and I think it's space.storage or something like that. It's a product built from the Fleek folks. Both of those tools are you can now start using today and move around kind of with a traditional Dropbox experience. I don't know if anybody trying to add a DAO to that, but I'm sure that some other groups will be able to kind of build products like that. How do you address real-time data processing? Is it possible to do so using the FEM? So the real-time data processing, so think of using the FEM to introduce a task scheduler into the network that you can then hang other computation frameworks out of, right? So think of the FEM as giving you the primitives and the hooks, so the computation on chain to build then a task scheduler to then issue out computation jobs. So step one is introduce the FEM to add that part of computational layer and computational primitives, and then from there you then deploy a task scheduler that can do these other computing jobs. So think of like we sort of describe these as compute over data networks, where you build, and there's a lot of kind of constraints about the problem space of doing computation on data. When you think about people trade off different characteristics. Like some people really want performance and cost efficiency. Other people really want hard verifiability, that every kind of instruction was done correctly. Some other people can give out on that. Or if you want perfect secrecy, where privacy is paramount and no bits of information can be even seen to the computer running the network. And so those three primitives are really hard to trade off against each other. And so I expect there will be different computational networks that tune for these different primitives. Some of them are going to kind of give you the highest performance or cheapest computation, but they're going to have to give some on the verifiability or the privacy, or systems that then use full cryptographic methods like MPC or FHE or things like that, but they're going to be more expensive and slower to run and whatnot. And I sort of expect us to follow the pathway of machine learning, where you have compiler tooling associated with programs. So, today you see a modern machine learning program. People tend to use, the standard programming languages of their choice, whether it's things like Python or Go or Rust or whatever, and they have tooling embedded into their programs to then issue machine learning jobs from within some larger application. And this is kind of very common with TensorFlow and other things like that. And to think of all of these computational clouds being able to be weaved together through that compiler tooling. So you can do things like, this part of my program I really care about being really fast and cheap, but I don't really care about the secrecy component, or hey, in this component I actually need the cloud to not know anything and I'm willing paying for it. So then you can use FHE or MPC or some component like that. So yeah, in terms of real-time data, like that'll come with those computational networks. It'll be kind of another component. I would expect the applications that don't care about real-time data to kind of scale first, because that's just a much easier problem to solve. Like just getting the computational tooling to issue long-running jobs and data pipelines and whatnot working. And then I would expect sort of the real-time data processing to arrive right after. Although who knows? It sort of depends on people going to build those kind of components.
Awesome. All right, thank you so much, Juan. I think we're a little bit over, but if you have any other questions, please send them async. I'm more than happy to follow up with Juan. Thank you so much for joining. Very exciting to see what's coming out. And then we'll move over to our next presenter for today. So first of all, thank you for joining, Tim. Tim Peterson is the Senior Director of Product Management at Seagate and has been very engaged with his team with the Filecoin ecosystem in the last year. So we thought it would be interesting to hear from Seagate themselves on what their view is on Web3 and Filecoin in particular. So Tim, welcome. You can share your screen and you have the floor.
All right, thank you. I appreciate the opportunity to speak with all of you here, and I'm excited to be here. Can you guys see my screen okay?
Perfect.
Okay, cool. So first off, just to give you a little preview of what I'm going to talk about. Really interesting in terms of what's going on in this space. I think a lot back to some time in our not too far back past where we were talking about cloud in the same way that we were talking about Web3 today. So pretty interesting. So I'll cover a variety of topics, and I'll cut to the punchline. At the end, let's connect, because we're really excited to be part of this community. So some history about me. So I'm a longtime person in the storage industry. I've led pretty much all of our major verticals at some point in time from a planning and strategy perspective. But one of my roles in the past was I was the first team lead for our focus as a company on cloud in 2012. And as I said before, what's going on in Web3 feels very similar to me to, what was going on back then. So as you all know, Internet Archive is a really good partner to Filecoin. So if you'll allow me, I'm gonna put us all in the Wayback Machine, and we'll jump back to 2012 and compare it to now. So what's how do we think about what was going on in 2012 versus now? Back then, people were saying, well, what is cloud? How will it transform business? But back then, those questions started from some of the financial analysts talking to some of the OEM companies. Big global OEMs were getting those kinds of questions. How are you participating? How are you supporting it? And now, if you see some of the financial analysts talking to some of the large CSPs and asking them, what their Web3 strategy is and how they view it as a transformative technology. So, the shoe's kind of on the other foot for the big CSPs. So pretty interesting how that evolved. Seagate, back then we were talking about, learning about hyperscale technology and what the architectural needs were for hyperscale. Now, we're very similar in the sense that we're thinking about, what kind of technology we can bring to this market, but it's more about, decentralized storage. And, the fundamental difference now versus then is, we're able to, live the dream along with the storage providers because we can, deploy our own storage, our storage miner capability to learn more about some of the challenges. Back then, also, like I said, we were looking at providing innovative solutions, devices, systems, and services. And I'll talk a little bit more about what we have to offer for this space today. But I also want to put it out there that, what I'm going to talk about later on in this presentation is just the beginning, because, we're rallying the troops within Seagate to support this community. So more on that later. Back then, one of the key differences was we engaged from a technical perspective with a very few number of companies. There's really, the top 8 global CSPs, and we worked with them in silos. Back then, we used to do individual programs that we called, JETs, so joint engagements on technology. But now, what's different about this space relative to any other of the verticals that I've worked on in the past is this element of community. And it's a really important concept that makes what's happening in the Web3 space unique. Really, so the way we think about this community collaboration, it becomes the superpowers. So all of you working together and being here today through the leadership of Protocol Labs, along with PiKNiK, adding Seagate and AMD, is enabling superpowers for this space to grow and be disruptive, not only from a business perspective, but also from a technical perspective. So super interesting, and really excited to see what PiKNiK's doing here along with Protocol Labs. A little bit more about the evolution. And if you look at the technology, some of you may be aware, some of the first systems that Google built are, this one in particular is sitting in a museum in the San Jose area. It was a lot of cables, zip ties, and duct tape. Really, if you think about the rise of the cloud, the modern cloud data center took about 10 years to get to the, something looking like the picture that you see on the right. So super interesting to see how quickly the technology evolved. As we think about the rise of Web3, we got early pictures of mining hardware that people were deploying, and it was kind of interesting to think about it in the context of how Google got started. And we didn't see much duct tape, but plenty of zip ties and cabling. And then the question becomes, as we think about the future, if it took 10 years for the initial cloud servers to become the modern cloud data center, it's really interesting for us to think about the rise of dStore and what that'll look like in 10 years. So pretty exciting. So internally, we talk a lot about relating crypto to Web3 and dStore. Certainly, the crypto associated with with this space is important as a mechanism to facilitate commerce, trading in goods and services, like what's going on in Filecoin, and on a greater scale, what's going on in Web3. But as all of us here are particularly interested in, we're thinking about decentralized storage as one of the key elements necessary to support the Web3 apps. And Juan talked a little bit earlier about how Filecoin is interfacing with many of the other blockchains to be able to facilitate it, such that Filecoin will become the decentralized storage network for Web3. So pretty interesting. There's a lot to unpack in this chart. So I talked a little bit about cryptocurrency and its role as part of the Web3 ecosystem. Blockchain as a technology being trustless, forcing verifiability is absolutely an important element. And then all of the user apps that are being built on it. Stefan talked about NFTs, and there's a lot of discussion on DeFi and gaming and other applications that are being built. And the other element being IPFS. But most notably for us and important for us is the Filecoin piece being the foundational element of the Web3 ecosystem. And at Seagate, we're thinking now about how can we bring together our portfolio of solutions, data storage, data mobility, data migration for the benefit of this ecosystem. So we have a wide portfolio of different products and services. I'll talk a little bit more about those, but ultimately we see that we have a lot of things already on the shelf that can help this community, and we'll look to do more in the future. Okay, so this chart, I like to talk about, as kind of why we believe, and what shows us that Filecoin really has legs. The chart on the left being the number of storage providers, many of them, being smaller companies. Even 88%, I believe, is the latest statistic of the storage providers are less than 10 petabytes. So it truly is a healthy decentralized storage network and growing. And then, Juan talked about Filecoin Plus, so, more and more clients are coming to this space. And, we expect that to grow, and, certainly, having more and more valuable data moving over to the Filecoin space will show that it's really growing. Thirdly, in the lower left, certainly exciting to see the number of businesses that are being founded on Filecoin at various stages of funding. That shows that there's a whole bunch more new commerce that's going to be built on this blockchain, and companies are really looking to innovate and add services on top of the Filecoin blockchain. And last, but certainly not least, is the developer adoption. Juan talked about the number of hackathons that are planned for the future, and the fact that Filecoin is the fourth most actively developed blockchain is super exciting. Some of you may be familiar with some of the interesting things that like Steve Ballmer would say in the past. One of his favorite moments was at an all-employee meeting about him chanting about the value of developers. And if you want to chuckle, you can kind of go, you can go search that and take a look. But I think there's applicability to Microsoft way back when, and even more recently, as I mentioned before, some of the big cloud service providers are taking notice. And recently, on the Twitter earnings call, their CEO talked about the incredible amount of developer activity and excitement in this space. And that really, shows that there's potential strength, in this space for it to grow into the future. Now let's talk about, the growth in the Filecoin network. And, if you just look at this chart on the left, this is just, essentially over the first year growth, the first 15 EIB. Just to put that into perspective, that's roughly 1% of all of the HDD exabytes shipped last year. And that's a huge total from zero to on the radar in 1 year. Just an incredible growth story so far. And if you look at the chart on the right and you purely do a mathematical extrapolation of those numbers, we'll be talking about 225 EIB in only a few years' time. So, incredible growth to date. And if you think about that growth in the future, it's pretty exciting how the pace that it's on. So, Okay, so, and if you just step back from that and you step away from all of the applications that are going on in Web3, and you just say, okay, so how does this compare to what's going on, and what could the impact be to current Web2 cloud services? And so we think about it in terms of Clayton Christensen's model of disruptive innovation. And in terms of performance level over time. If you don't know much about Clayton Christensen, he's considered to be one of the most influential business idea leaders, in our time, and literally wrote the book on what is disruptive innovation. So, as we all know, Filecoin is really focused now on public data, public archives, but we also understand, based on what Juan has been talking about, that there's intent to grow the applications and move beyond some of these applications to higher levels of performance requirements, and it fits really well with Clayton Christensen's model. And from what we see in terms of how Filecoin is, approaching this market. And if you just give you a sense for how big this market is today, for cloud storage services, we're talking about a $40 billion in a year annual market. Just an absolutely huge market that's already using cloud services. And there's just a ton of room for growth. As Filecoin is able to expand the SLAs into the future and become more and more of a disruptive technology. Okay, just a little bit more on how we kind of think about the ecosystem, and we started kind of mapping this out in terms of how we think about it. Certainly foundational layers associated with the Web3 software stack related to the blockchain protocols themselves. But also, there's some other layers within the software stack for Web3, related to data migration. And there's an important aspect of the capability to bridge and move data from Web 2 to Web 3. And then certainly, right in the middle here is the Filecoin Storage Marketplace. And, as we sit here in terms of the, this ESPA event, these accelerators are, kind of, providing the, the water, the fertilizer to help this space grow. Which is super exciting, to be here with you guys, along with PiKNiK and Protocol Labs, to kind of, help this ecosystem grow through this community. So, but longer term, what blossoms off of the foundation, the branches and the leaves of the trunk of the tree, are the applications themselves: web publishing, public data, gaming, video, NFTs, with many more to come. But all of these have to work together to become the ecosystem to build this technology into the future. And it's really interesting to see all of them coming together concurrently, as we've been watching over the last year. I'm going to switch gears on you. My intent is not to go full commercial. But I'll talk a little bit about some of the Seagate solutions. Most notable is our Exos Core Vault systems and JBODs. Really high density systems, high capacity, shipping with 18 and now 20 terabyte drives. We have something that's related that we call ADR technology, which is really allows the system to be self-healing. Without support from the host. It does some of its own management, of the disk recovery, which we think is really exciting for the Filecoin application. And, as our core technology is disks, we've done a lot of features within some of these systems to optimize the capability of the disks that we put inside them. So, we think they're really well suited for Filecoin. So here's a little bit more about Core Vaults and JBODs. kind of as I talked about some of the things that our core vault will do, in terms of the self-healing technology, we think it's got great applicability to help reduce the risk of slashing costs. We are shipping in volume with both 18 terabytes and 20 terabytes in our enclosures today. So that's pretty exciting. We're working with software partners. We built in levels of resiliency. The self-healing that I talked about is a great TCO solution, and has some built-in security features as well. So more on that later. On top of that, we have a portfolio of live mobile solutions, and they are essentially shuttles that can be plugged in for rack mount capability and enable mass data transfers offline, without having to worry about, in particular where you have limited network bandwidth. So, we've been having discussions with a number of storage providers as they think about bringing on client data to leverage some of our live mobile portfolio for those applications. So what's important about live mobile? By its very nature, it facilitates edge type applications and data movement. It's that they're fast and secure. There's a number of security features for data to be protected when these shuttles are in shipment. We have a variety of different sizes and form factors depending on the scale of data that you need to move. You can manage this via an OpEx model, and there's no network dependencies that I said, because you're basically shipping large blocks of data to your final destination. And lastly, we have a number of migration services. Most notable may be important as you play in the archive space, being media migration. So whether it's tape, optical, or disk, or some kind of flash storage media, we can help you work with clients to convert that data to a live mobile shuttle, so that we can move data to your storage provider nodes. And like I said earlier, fundamentally, we just think we have a full portfolio for all of you now, and we're just going to keep working to expand our solution set because we want to support this ecosystem in every way possible to help it grow. So here's kind of my last slide. I probably made up a little bit of time. Collaboration's really your superpower. I appreciate the community. Thank you to PiKNiK and Filecoin for bringing us here together. I think it's great that's what's happening. Like I said, I think we have a lot of solutions today. We're super excited about this space. Stefan probably gets tired of me sending him updates on things that we're doing.
Yeah.
But we
but it's all great. I love it. I mean, I just want, it's amazing, all the collaboration here, and the fact that you're so engaged with the ecosystem, Tim. So thank you for that. I didn't want to interrupt you, but go ahead.
No, it's all good. It's all good. I can take it. So, my last piece, and I have some of my colleagues here if there's, technical questions that need to be answered. Otherwise, you can just, contact us on, basically on Seagate.com, reference Filecoin. If you go to the Seagate website, or just send an email to filecoin.seagate. I don't know why the dot got in there, but it is. So maybe it's first name file, second name coin, but we can answer you that way. And I'm even willing to give you, my personal address. So if anybody wants to reach out to me personally, I'd love to hear from you. Like I said, we're really excited to be here, excited about what you guys are doing, and we want to be part of this community.
Awesome. Thank you so much, Tim. Don't see any questions on the chat, but if you have any, as Ed pointed out, there way to connect to the team at Seagate. So please don't feel afraid to reach out. I know we've been working very closely together in the last couple of months, and you've helped a ton of storage providers already. So we're very thankful for that. Moving on to the next. Thank you, Tim. We'll see you in the next event. Appreciate it.
Sure.
It was a great overview, and thanks for Seagate's dedication. We'll move over to AMD. And after AMD, we'll do a short break, but very excited to have York. York is the head of blockchain at AMD. And we asked him we're going to ask him a couple of questions. Give us one. Last couple of months. We're very excited because all right, welcome everyone for another session at this virtual bootcamp here this week. Today, we're very excited to welcome York from AMD, who is the head of the blockchain business out of Germany, and who's been working very closely with the Filecoin ecosystem for the last couple of months. We're very excited because today we have more than 3,900 storage providers that are using AMD processors in the Filecoin sealing nodes. So these processors have been very crucial in improving the sealing rate of our ZK snark process. And so today we're going to have a short conversation on how York got into the blockchain world and tell a bit more about AMD's strategy. So first of all, welcome York for joining us.
Hello, Stefan. It's a pleasure to be here. Thank you very much for this opportunity.
York, how long have you been in the blockchain world, and what's your background, and how did you get to hear about Filecoin?
Excellent, good question. So it was quite a journey, but maybe I start from the beginning. So after my degree in computer science, I was working 7 years for Fujitsu Siemens computers that time, responsible for the high-end notebook system that time. And so we invented a couple of standards. So MXM-based solutions around the GPUs, and the first notebook system with an active rate controller on board, which was quite exciting. And then I switched to AMD, where I'm working now since 14 years in different areas. So in the server area, in the client area, as well as in the embedded area. And then since more than 5 years now, I started to investigate into the blockchain ecosystem. And it was starting all around Bitcoin and Ethereum, majorly about the mining stuff. And but already at the start, seeking around, okay, there must be more than only cryptocurrency mining. And this was initially the start for us to think about to generate a blockchain business unit, leveraging what are the enterprise applications we can work in, where we can improve the workloads, and what are the requirements to be in that area. So that since more than 3 years, we founded the blockchain business unit, and working in major 3 key pillars. And those are enterprise business. This is exactly where we see distributed storage. This will be in the gaming area, which is also a fantastic area, but maybe I can tell you a little bit more later. And consortiums activity, because as we know, blockchain is a new technology, and we all need to sit together to define standards to get it processed in the right way.
Awesome. Yeah, great. Sounds like you've been in the space for quite some time. That's amazing. And how did you, or when was the first time you started working with Filecoin specifically?
That was also a very interesting part. So we started to work on Filecoin around 2020 with a couple of partners and customers. And one of our major partners at that time was ElioVP. So we worked of different enterprise solutions and specific around data centers, where the first time we connected our EPIC CPUs with our Instinct graphics solutions. And this was quite experiencing because we always looking for new algorithms, for new technologies, and Filecoin was a very promising algorithm and a very promising workload. We thought in the future will become very successful.
Great. And for those who don't know it, ElioVP is one of our storage providers out of Europe, right?
Exactly.
So great. So it sounds like you started off with one of our SPs and got involved into the ecosystem that way. And that's great. So what has been AMD's leadership in Web3 overall and in Filecoin? What's your take on the future there?
We work with leading companies in this field, including the founder of Filecoin, together to integrate AMD reference architecture into cutting-edge solutions intent for the global market. And I think that's a major point here. So looking for the right partners and the right development to drive the ecosystem and the idea around distributed storage in Filecoin. We always aim for higher computational power and efficiency to optimize our hardware in order to maximize the energy footprint or the carbon dioxide footprint and simultaneously enhance the security, latency, scalability for the Web3 industry. And I think that's also a major point to mention. So all the time we start with a new technology, there is always room for improvements. And I cannot tell it more enough. So for us, it's a kind of a deja vu in terms of the challenges we see around blockchain and around the algorithms that we facing challenges specific around latency, scalability, electricity, and also security. And those 4 pillars are the key pillars here to get further driven by our hardware infrastructure. So improving the process node, always shrinking it from one architecture to the next architecture, thinking about new solutions to get built in, combining it with the software architecture. So on our side, it's the ROCm API we drive, where we connect the GPU with the CPU business to get it perfectly integrated into the solution. And last but not least, getting the carbon dioxide footprint as low as possible, because this is one of the most important points for our end customers, specifically talking about data centers to improve the ROI index, the return of invest.
Yeah, no, I mean, that's agreed. Like a lot of our SPs are looking at green initiatives or are driving lower power consumption as one of their key initiatives, right? So thank you for having that as a target as well. But how do storage providers benefit from AMD's processors, and how do you, like, you kind of already mentioned it, right? There's a couple of pillars that you're working on, but I assume you're also running it in your environments. Your engineers are optimizing your processors for it. And can you maybe talk a little bit more about what AMD is doing specifically for storage providers?
So there are a couple of points I would like to mention. So first of all, one of the key initiatives is definitely the capability about our multi-thread capabilities on the CPU side of things. So as we have seen, a lot of our partner engagements, they are using 2P server ecosystem. So that means they can put 2 processors in. One processor, one EPIC processor is coming with 64 threads, 64 cores and 128 threads. If you multiply this by 2, we're talking about 256 threads we can use within one server instance. And this is very important, specific once it comes to parallel threads. So that means specific for the sealing process, this is very beneficial to run as much as possible instances for this kind of calculation within a single server unit, very dense and very power optimized. In addition, they are also security mechanisms which are inside each and every processor, as well as graphics. And this is called PSP, Platform Security Processor. And this is an ARM RISC development where we have an independent ARM RISC processor built into our CPUs as well as on our graphics cards to cryptographically secure the transactions between memory, between the CPU, the graphics, to enhance the security feature at the maximum level.
Cool, awesome. Yeah, I appreciate your walking us through that. So looking at, that's a little bit more on the technology side, but looking at the future now, how do you think, from your perspective, the blockchain world in general, and Filecoin as a part of that, will change the enterprise landscape?
That's a very good question. I personally think that we are in a paradigm shift. So since years, a lot of people in the industry is talking about Industry 4.0. So we are working day by day using computers. And I think a big accelerator, definitely we have seen with the COVID pandemic crisis. So people got taught at home, so our kids got taught at home. People were working from home, so they need computers, notebooks, data center infrastructure to get videos recorded, to speak with other people and developers to drive projects forward. And if we see this as a kind of a roadmap overview, I think we are now in the Web3 area since the Bitcoin white paper in 2008, and this has been further developed, as I mentioned before. So with the Ethereum algorithm, the first time we get the capability about smart contracts. And with the smart contracts, you get new technologies in the market, like the first stable coins, decentralized finance, the non-fungible tokens, and the Filecoin as to the metaverse, which is the current technology, which is heavily driven. And by the way, all those technologies, just talking about distributed storage, talking about the metaverse, they all need the basic, I call it blockchain API underneath. So for example, if we're talking about the metaverse, we need the distributed storage. We need the NFTs as the digital rights management, and we need the crypto to get the transactions processed and paid between the partners within the community. And that's a very interesting part. So I think this is a kind of a paradigm change we are. And this is a similar paradigm change as we already have seen in the history with lots of other technologies. And it will really fundamentally change the ecosystem and also our thinking to get problems solved. And yeah, just thinking about decentralized systems, I think one big aspect is really that decentralized peer-to-peer aspect about a blockchain ecosystem, which is growing in every direction in the industry. We see it with NFTs, for example. So NFTs, I always call them as the next level of a digital rights management. A lot of customers and a lot of companies are moving into this digital rights management. Why? It's secure, it's not hackable, not two people at the same time can own it. And you can build up a much stronger trust level and ecosystem for your products. Just think about licensing model for software, or in the movie industry, or in the music industry, or in the art industry. It's a big new fundamental change. And going the step forward, all these needs to run in a data center on a storage cluster. And this is exactly just to envision distributed storage and Filecoin for the next couple of years will become essential to drive these new technologies.
Yeah, I couldn't agree more. Thank you for that. I mean, today we have more than 40 million NFTs stored on Filecoin and growing, knowing that, a couple of months ago it was single digits, so we're growing really fast. I also believe that down the road in the future, anything you create in a digital world will be stored as an NFT. So I totally agree with you that the security aspect, also the this decentralized component makes it a lot more secure, and in general, like you said, brings in a lot of new features, right? You mentioned you had a couple of pillars, right? I think it was enterprise pillars was one of them. But can you explain? Can you go a little deeper there? Like, how does AMD look at this, and what are you doing in that space when it comes to enterprise blockchain solutions?
Good question, Stefan. Yeah, so we call those pillars verticals, and so one vertical is the enterprise business. So beside distributed storage, and that's exactly the point why I strongly believe it will become very successful, is distributed rendering, where we worked before already successful with different companies around the globe to tokenize render jobs. It's a great thing, specific. Everybody's talking about moving computational efforts into the cloud. But yeah, we missed the security part of that, and just talking about rendering capabilities. If we go into the movie areas or for the car manufacturers, security is a must given and the strongest argument in that field to sustain. Another one is medical area. So just think about genome storage or genome calculation. So there are a couple of basic ideas which are requiring a decentralized ecosystem at the highest security level for the customers. The second vertical we are working with is in the gaming industry. Also here, I think this is a very strong growing segment in the next couple of years, because just imagine about to tokenize in-game assets. That's the next big thing, because now playing games, you can earn money. And you can resell your character, you can resell items to other gamers in the community across the platforms, and that's the magic key. So, and I think this will open up a complete new world for the gaming industry. And if I just look into esports currently, so you can also do so many good things just for charity, so that the winning team is putting, maybe some stuff from their team for charity to the community. And it's a unique part. You can further enhance marketing activities. You can further enhance market-related fan engagements and all these kind of things, which hasn't been there before. And you can create collectibles. And I'm just thinking about how cool it will be if you can sell parts maybe from a game which is already 3 to 4 or to 5 years old, but collectors are still having them engaged in their wallets, and the value is increasing. Also, the second point about the possibility that you can track the supply chain. So you can also see maybe famous people have owned this NFT or this good inside the gaming area. Same, by the way, for hardware. So where you connect an NFT with the shoe to make it unique as an collectible, and to prove it's a genius item. And
no, it's interesting to see. I mean, you make a good comment. Is like bridging the physical world with the digital world, right? By using NFTs as a unique reference to that. Yeah, I see a huge opportunity there as well. I agree. Where NFTs become a very important part in our lives to identify that we are the unique owners, not just of the digital assets, but also physical assets, and then you can use that for collateral. You can use that to trade. Yeah, it's a lot of opportunity there.
I think it will become a kind of a standard. So just think about, and this is the same analogy here with the internet, mid of the 90s. So at the end, we had a standard, the IPv4, IPv6 protocol. Do you know how it works? I don't know it, but
Yeah.
I'm using it every day, right? So similar to blockchain technology. Today, we're talking about blockchain technology. We're talking about the different algorithms. But I think in a couple of years, it will become a standard. And this standard will be used in lots of applications. And this exactly comes to the third vertical we are working in, and this is consortium activities. So 2017, for example, we joined the Enterprise Ethereum Alliance to work with them specific in regards to security implementation, because also here there was a new point to get considered. And this is a very important point because in that consortium, we're also working with our competitors, because we need to make sure that everybody in that decentralized manner can work together, right? So that means you need to rely on open standards. It doesn't matter if it's the API, if it's security, it must be a kind of an open standard, at least an open basement everybody can follow, because a decentralized system doesn't make any sense if only one party can join and play with it.
Yeah, I think I totally agree that the technology is only as successful as its adoption, right? So and that's what we're driving together. Amazing. No, it's great to see that our visions are very aligned. So thank you for that. What has AMD done in the Filecoin space in particular? Have you done any testing? Can you go a little bit deeper on that and tell our storage providers what AMD actually is doing on a day-to-day basis with Filecoin?
So I remember the work started already beginning of 2020 to go through the white papers and to work with partners, specific Elio that time. So about the concept and the implementation. So there were different ideas in the early beginning. I still remember where we investigated into consumer hardware at a small level. And then we very fast, we found out, this doesn't make sense. So we need to raise density. Why to raise density? To get more computational power through, and this is exactly what we have discussed before. So having the multi-threads used as much as possible, going away from single instance or single compute nodes into heavy server-oriented processors, where we can have that many cores to have as many as possible parallel threads. So the mainnet has been launched in October 2020. And since then, we are interested in computation heavily Web3 workloads for our hardware. We started investigating in disrupting file storage in general. This was also very interesting. So, and investigating into the protocols, also in the algorithms, starting the first benchmarks, looking, okay, where we are, where the competition is, where are the bottlenecks, how can we improve it, specifically, not only in terms of performance, also in terms of how we can get the best efficiency out of the system, because at the end, it's all about efficiency, best performance, at the best level of electricity usage. And then we found Filecoin is the best solution out in the market. And specifically having a very motivated team and a great vision there. And I'm a strong believer in that system. And this was the start. We thought, let's go in, become active, working with different partners like protocol labs and teams, and getting EPIC fully adopted and optimized in terms of the software API, and find out how to get the best possible performance specific for the sealing process and the Merkle tree generation, which is demanding a lot of threads, and which is fantastic to see.
Excellent. No, it's fantastic to see that the team is like very involved. You're doing benchmark testing. You've been there since the beginning. That's amazing. So what about ESPA? Why are you joining the ESPA program, and how do you want to be involved in this?
So it's always the same story. So if you talk about new technologies, you need to go with startup companies, and you need to look for the first adopters. And ESPA is the first accelerator program in the Web3 space. And focused on the storage provider, and that's the important part. So they've combined all the parties to make the system up and running. So you have the silicon vendors, you have the storage providers, and you have the software ecosystem to get a perfect solution out there. And we like to support open projects, as I mentioned already in the beginning, because I'm a strong believer into open projects, which will be key for this ecosystem.
Awesome. All right, thank you so much. Any other closing notes, Jörg, that you want to add? Maybe something about the future, or where you think the market will be, or maybe anything else that you want to share with the team?
So I think all the time with technology similar to the internet technology, we are at the first beginning. So maybe still within the first 5% of the development curve. So that means there's lots of room for improvements, lots of room for engagement with different companies, partners on different applications. But I think over the next couple of years, blockchain technology will be further developed like the internet. So for example, currently having problems or challenges within the latency, the scalability, and the electricity. By the way, similar challenges we had with the internet, just remember end of the 90s. And this is specifically one part I always want to focus on. There was a good article in Forbes where they calculated that one Amazon transaction will cost 1 pound of coal. And if you multiply this with the people on planet Earth, then our ecosystem will explode. So I think we are in a similar situation, and this is exactly where we need to drive our engagement with the community, driving further steps in terms of hardware development as well as in the software development. And I think this is all time the same experience. Just think about the first car. It was running, but it was loud. It was maybe not so good in terms of pollution, but it got further developed, right? And so therefore, technology will be a key to bring the next level into success. And this is what I strongly believe. And this is where AMD is always focused on improving the products and the customer experience.
Yeah, that's a great way of ending it. Together we will improve the innovation, drive innovation, and provide better customer experience. I couldn't agree more. Well, thank you so much, Jörg. This was great. Glad to see AMD as one of the leaders here in our ecosystem and helping the community and driving better solutions. Thank you for all the support. Looking forward to many more years of collaboration. And with that, we'll move over to the next section. But thank you again, Jörg. Have a good night, and we'll see you on the next presentation. See you.
Thank you very much, Stefan. Bye.
All right. So as you can see, that was recorded. As Jörg is based out of Germany. We do have, I think, Bogdan on the line. I know we have another presenter lined up before we go into a break, a short break. So maybe we'll move over to Supermicro next. Vic, I don't know if Vic is on the line.
I am.
Welcome. So great discussion with AMD. It's very exciting to see multiple vendors here presenting today. Oh, Bogdan is on. Hey, Bogdan, great. Have a look in the chat. If you have any questions for AMD, by the way, just put them in the chat. Bogdan is part of the AMD organization. He's chiming in. So, okay, let's move on to the next. Supermicro has also joined us. Thank you, Vic. Maybe tell the audience a little bit more. You're dialing in, I assume, from Europe as well, if I'm not mistaken.
Yes, actually, I'm based in San Jose originally, but I'm here for Mobile World Congress. So I'm in Barcelona right now.
Oh, nice. I'm jealous. Well, enjoy Barcelona. It's probably warmer than here, but well, thank you again. Like, look, we're very thankful for our supporters, and we appreciate you joining us today. So the stage is yours, I would say. So please share with us and the community what Supermicro is doing in the Filecoin ecosystem and why you're such a believer in the Web3 and Filecoin. So thank you.
Absolutely. So let me start, sharing my slide deck, and then we can go from there. Let's say. Let me get into presentation mode here. So first of all, thank you very much for having me personally. I'm, quite excited about Web3 technology as such, because it's a game changer, as every one of us here in the room know. And I am Vic Malyala. I am the president for Supermicro EMEA, as well as I manage the worldwide field applications engineering for Supermicro. I've been in the company for over 13 years. And before that, I was an ASIC designer developing multiple generations of chipsets. So, when I see the technologies coming together, it always excites me quite a bit. So without further ado, I want to give a brief overview about Supermicro. So as a public company that is established in Silicon Valley back in '93, we got our name and fame from developing application optimized server building blocks. That's how it started off, which basically based on Intel x86 servers at that time. And over a period of time, we have evolved and we started focusing on complete solutions, fully integrated rack solutions and whatnot, Intel AMD based. It's a company that we expanded into other geos. So we have office in Netherlands, and we have in Japan, Korea, and all that stuff. We have about 4,500 people in the company, and more than 50% of that is engineering centric. We are one of the top 5 in terms of unit shipments for the server industry in x86. So this is like some data that I'm presenting from IDC. What you can see here is that Supermicro as a company, we work very closely with our partners, whether it is related to our channel partners that are taking our solutions and enabling the customers, or customers that are taking our products directly. So what IDC recognizes is the ones that goes in as Supermicro branded. So that's why you see the number around like 4.9%, but realistically it's between 8 and 9% with about 1.2 million units that we ship every year. Before we jump into the crux of it, I want to give some background on what we are trying to do and why it is relevant to this industry. If you take a look at our product line from Supermicro, we have been investing in our product portfolio to bring different variants of technology together. So at a very basic level, we're talking about compute, storage, and networking, and how we bring that together. So when you take a look at the platforms that are going into the data center side, it ends up being very high in efficiency, and you need to have something that is highly performant, depending on the type of data center and what kind of workloads that we need to be working on. It could be a standard 1U or a 2U pizza box, or you can have multi-nodes such as blades and whatnot. At the same time, over a period of last 7 or 8 years, we are seeing a lot more adoption of accelerators. That accelerator could be FPGAs or it could be GPUs. So we needed to bring them into the platforms. So a lot of platforms are developed to accommodate these accelerators. And in terms of storage, it has evolved quite a bit from a SATA or SAS devices in the past now to NVMe, which is de facto standard for high performance local storage. And at the same time, we also have a need for people, for the systems to be supporting both front and rear I/O, depending on which kind of data centers it go to. Now, every one of us talking about 5G, telco, and smart edge devices and whatnot. All these things require a small form factor. The systems are going to be potentially deployed away from a data center, but at the same time, they need to have the same availability and reliability of the systems that are going into the data center. So we kind of expand the portfolio from core to the edge and bringing the technology, but from the lowest end of the processors to the highest end of the processors, and it goes from there. Depending on that, of course, enterprise or high performance computing or hyper convergence, so on and so forth. Here, I'm primarily focusing on the product portfolio that we have developed based on AMD, mainly because we have seen in the last few years, AMD has changed the game by bringing a lot more processor cores and high performance. In that, they were the first to bring PCI Express Gen 4 into the market. So because of that, certain platforms can actually take much better advantage of it. I will get into the details as to why AMD that I'm talking about currently. But when you take a look at these platforms, what we started with is the platforms that actually can support a dual socket, lots and lots of memory. It's about 32 DIMMs, for example. Why? Because by having more number of DIMMs, one can actually get to a higher capacity memory, higher memory density in that, without having to go for a very high cost memory modules. The Ultra platforms is a classic example for that. And then when you are looking at a single socket platforms, you can still have all the benefits, mainly because of AMD processor, which is the EPYC series, having 128 lanes of PCI Express. So this gives us the ability to have more networking cards or more GPUs or more storage directly connected to the processor. And there are reasons why people will be using multi-node. They can bring a lot more density into the rack. So which is the reason we have either 2U with 4 nodes or 4U with 8 nodes. And we also have a blade which supports 20 nodes in a 8U form factor. Accelerators is something that I mentioned. One of the things that we look at is how we bring the right balance. So we do have a dual socket platform that can support up to 8 GPUs, but on the far left is what you're seeing is a GPU platform. We call it a 2U 2 node, where on a single socket, we are able to support 3 GPUs. I'll get into the details in a sec. So now coming to what we are here for. When we take a look at the technology, how it's evolving, the Web 1.0, we know that it's basically getting some data from a server onto your browser. It's as simple as that. And as we look into the Web 2.0, which primarily we are using for the most part, where we are talking about a bidirectional communication, primarily from a centralized server. And we are able to do pretty much a lot of things. But then when you really want to have moving to the Web 3, which is where we are talking about a completely disaggregated components, which basically going to support us to run all these new protocols that is needed, and all the technology that is required for us to take it to the next level. Single system in a single location is one thing versus having peer-to-peer communication, having multiple devices that is able to provide all the content that we want in an effective manner. That is where we are headed. And in order to do that, we need to figure out a way to get the rightly sized building block. That actually can help us to build from that into any solution that we are looking for, depending on the scale that we are going for. This is a very quick slide in here. And when we are looking at a compute, the compute can be a single or multi-socket, as I mentioned. And a storage point of view, at one end of the spectrum, we are talking about very high performance parallel file system supported using NVMe all-flash arrays. And the other end, we are talking about high capacity storages using the top loading storage, which can get to a petabyte type of storage in a single box, which is not going to be great for performance, but it's going to help with capacity. In terms of accelerated platforms, we are going to have a lot more GPUs. So in a product categorization point of view, compute, storage, accelerated compute, and the edge devices. These are the four broad categories that we are focusing on. When we start applying these into what we can do with the requirements here is, whenever we are looking at a standard system deployment in an enterprise data center, we look at basic criteria. What is the performance that is required, and what is the balance of the processor to the GPU to the networking that is required. So in some cases, people want to have all the GPUs to be hanging on a single PCI root complex, or you can have something that need to be connected to the processor using this PCI by 16. So you have unrestricted bandwidth. And once you have this balanced system, then you're talking about what kind of software that need to run on it and how do we ensure that it is qualified. When you deploy systems at scale, the big issue that you will have is performance per watt and performance per dollar. Nobody wants to spend any more money than that they need to spend on something. But at the same time, people want to be running the systems more efficiently. You don't want to be spending your dollars on the cooling of this equipment, but you want it to have as efficient systems as possible. Form factor becomes an important thing. Most of the times people like these 1U, 2U pizza boxes because it's easy for a single person to handle it, versus people who are having a lot more power and ability to handle the systems at scale can use multi-node systems. And that's where the density will come into picture. And environmental impact. You want to be developing these systems in a way where these guys will run for a long period of time, they don't break easily, and we will consume less power, and we'll be able to reduce the PUE close to 1.0 to the best we can. And these are all the ones that will help with the environmental aspect of it. And when you deploy at scale, another thing also important is to be able to manage the systems easily, some kind of outer band management or in-band management tools. When you are able to, when you need to upgrade or downgrade systems, we'll be able to have a way to do that very quickly. All of it will come into the total cost of ownership. The thing about Filecoin is, if you take a look at all the requirements for that, this is exactly same as what is needed for the systems to be deployed in a large scale in data centers. So this is the reason why the systems as they are used in a data center level, when it's sized right for this application, it's going to provide the best value and best performance. So what are we doing here? If you take a look at it, when we work with ESPA, the initial requirements were like, hey, we have all these different hardware that we are working and we have in like a building block, but we don't know necessarily what is most optimal. So in order to do that, we have to work together. And with the Filecoin, when we are implementing on our systems, we need to see the different phases of the compute. We are talking about the PC1, PC2, and the C2 portions of it. And what we realized is that the PC1 is primarily compute intensive. So in which case we need as many cores that we can pack in a given system and on a given per node. But at the same time, when you have a lot more cores, you also need to have a lot more memory to support that. And in order to support bigger memory footprint, as I was mentioning, we ideally would like to have as many memory slots as possible. So we can go for a lower capacity memory, which is cheaper, but still will be able to get a higher overall system level capacity. And you would like to have NVMe support. And this is how we started. So a single socket EPIC 64 core and up to a terabyte of memory, and getting 3 of the 3.84 terabyte NVMe devices. And networking point of view, at the very minimum, a 10 gig is needed, and that's what we put it together. As we go into the PC2 and C2 phases, which is where we realize that having a GPU is important, but having more GPUs per processor will give us the ability to map it properly. So we picked this particular platform, which is a 2U2 node. The details are going to come in the next slide or two. So where each of these processors is mapped with up to 3 of the NVIDIA RTX A5000 GPUs, and which requires, in a way, we are able to support 2 of the 7.68 terabyte drives. And with more networking is needed on that one, we are going with 25 gig as a network controller. So the system, if you were to look into that, so let me see, this is the first system. So for the first phase, so this particular one, why it's important, I kind of mentioned that. First of all, we wanted to have something that is cost effective. We don't want any more bells and whistles. We want something that exactly optimized for that one. So we need to have the right mapping of a CPU to its memory. That is the first and foremost thing, which we were able to get in this particular platform. Second one is, today, based on the applications, we are using 3 of the NVMe devices, but the system can actually support up to 10. So depending on what would potentially be needed in future, this is kind of future-proof. But for now, 3 drives is sufficient, which is what is needed for the scratch space. And built the 10 gigabit Ethernet, we can have an option to have a specific card if you want by using an add-on card. But the onboard itself, we have a dual 10 gig, which will be more than sufficient, and in its enterprise-centric controllers, which will actually be sufficient for this workload. And from the processor point of view, we are able to get support for the entire spectrum of the EPYC processor family up to 64 cores. So that is the highest, so we are able to do that. And by having a 2 DIMM per channel, we are able to also reduce the cost of it. This is the platform, we call it the WIO. And so the platform point of view, it can do lot more features wise. It has a lot more features, but optimizing point of view, that's how we are able to get there. The second one we are talking about for the second and third phase is for the PC2 and C2 phases, we wanted to be able to support GPUs. So this particular platform I'm actually quite excited about, mainly because the design of this platform is to support both EPYC, as in, for example, the 3rd generation EPYC is called Milan. We support that. But at the same time, this platform is also designed to support the 3rd generation AMD Ryzen Threadripper Pro, which gives higher frequency per processor core. So for the, within the same platform, depending on what we are trying to accomplish, we'll be able to use the EPYC or as well as the Threadripper Pro. So it's compatible with both of them. And because we are able to put up to 3 GPUs, we would like to be able to have as much networking connectivity. So in this case, we have a PCIe Gen 4x16, which can actually get up to 200 gig per NIC. In many cases, people tend to use 100 gig because it's reasonable in terms of cost. And this particular system, the way we design is, it's a 2 nodes, one in the top, one in the bottom, and the power is shared. So you can think about when you have redundancy, instead of having each node having its own 2 power supplies, now we are sharing the same power across 2 nodes. We are sharing the cooling across 2 nodes, which improves the efficiency of the platform. The overall power consumption actually comes down because of that. So as I was mentioning, one of the important things is to ensure that whatever the compute that we are doing is energy efficient and green friendly. This is what we are trying to get from this particular platform. So these are the 2 what we have done. We kind of looked at multiple platforms, and finally we figured out that these are the 2 platforms that are ideal for what we are trying to do in terms of getting the right bandwidth, the right balance of the compute, the storage, and the networking and the accelerators. So where does it take us? If you take a look at the development efforts, we want to be able to create a solution that easy for people to adopt. So hardware is different from the software in the sense people who are good at providing hardware, they may or may not know the software that well, or the people who know how to use the software, they may not know the hardware aspect well. So we wanted to ensure that we are able to put these things together, validate it. So we are bringing the core competence from both teams, and we are able to get a solution. This is going to have enterprise-centric features, so one can actually take it and deploy at any scale. Second thing is the technology is changing. As you can see, every year and a half, we are getting new processors. The networking is getting faster and whatnot. So we are able to take the newer generation process from Intel and AMD, the latest GPUs from NVIDIA, and we are able to continue to validate. So our hope is to improve the performance per dollar and performance per watt generation over generation. So we're going to invest time in this one. The third one is the Web3 technologies itself is evolving quite a bit, and the workloads are going to change a lot more. So the goal of this is basically to continue to invest our time and effort in expanding the product portfolio that is going to be optimized for the new and the emerging workloads in Web3 space. And the fourth is to collaborate with ESPA to enable more storage providers in this system. Why? Because the whole idea of doing this is to ensure that one don't have to go through this overall exercise all over again. We wanted to make the adoption easy. We wanted to take the burden on ourselves to run these different workloads on this. And that way, whoever wants to adopt these platforms and deploy it at any scale, that's going to be easy. So this is where I'm going to conclude this presentation. Thanks for this opportunity. The excitement for me comes because of how we are able to bring our hardware and our expertise in designing the hardware and make it applicable to Filecoin applications and make it easy for people to adopt it.
Awesome. All right, thank you, Vic. Really appreciate all the supports over the last couple of months and the reference architecture that you walked us through, which is fantastic. So many of our SPs are using Supermicro, so it's a great overview on how to run and operate Filecoin system on a Supermicro environment. So thank you.
Thank you.
Again, we'll see you at the next event and at the next collaboration. All right, thank you so much. We had scheduled a short break, but unfortunately, we're a little tight on schedule, and we have the next presenter already lined up. Give it a minute or two. Vic, if you can stop sharing, please, that'd be great.
Yes, I'm doing it now.
And yes, so questions, maybe I'll take a couple questions. Are the hardware slides going to be available? So after this, all the recordings will be made available on YouTube, plus all the presentations will be made available as well. And they will be added to the long list of collateral content assets that will be made available after this event. So cool. All right, John Paul Farmer. I don't know if we have John on the call. Let's see. Well, maybe this is a time for a break. Let's do this. Let's do a 5-minute break. Is that okay, Jamie? Maybe we'll just do a quick break while we're waiting for John.
That sounds great. I will go ahead and get the break video rolling.
All right, we'll come back at 3:30. Actually, there's a video that we want to show you, so please have a look.
really excited about the Filecoin network and protocol, and the ESPA was a really unique opportunity to come in and get a hands-on, upfront, detailed look at some of the major participants, some of the major backers, and developers in that network.
Building connections and familiarizing myself with the community. Who are the other players in the space, potential partners, people you can work with, people you can learn from.
The community is so welcoming and it's so collaborative that there's no absence of information or resources or assistance for anybody who's interested in potentially becoming and onboarding as a storage provider.
Everybody comes in with a different perspective, a different background, but you meet the other people here and you notice that everybody was selected for a different reason because they all bring a different, unique perspective that collectively will benefit the community. New friends, connections, partners, the networking events afterwards, the ability to sit down with somebody over a drink and talk, have in-depth conversations about where they see things are going. Conference number one.
Being here at ESPA and seeing that they're going to have a total of 50 storage providers in the first year coming internationally, Nigeria, Australia, Europe. We're really globalizing this thing, decentralizing it. We'll see more and more demand from hopefully not just academic institutions, but more towards like mainstream business enterprises that will do both archiving and computation. Their day-to-day content has been really useful. And then obviously getting to see and hear Juan speak was kind of powerful. And then, things like the tax and accounting side as well. As we understand what kind of challenges the storage providers face, we're able to continuously improve our own product to make sure that, we're helping them in the best way possible. Big shout out to PiKNiK. I think the entire team is really incredible, and getting to meet them in person after we've been talking for 10 months has been really, really cool. Really, really impressed by what they've put together, and I think it's great for the entirety of the ecosystem.
We're finding that we kind of even underestimated the size of the market, and it's one that's even bigger than we expected. And I think everybody here is here because they see the potential. Watching some of the talks, I have even better understanding of all the different players that are in the space.
So there's some telecom, there are some startups. It's actually just the diverse population of the people here. We decided to join the ESPA Accelerator program to give us sort of a leg up and move faster through deploying the technologies than we were doing on our own. With the Filecoin network, we're gonna end up migrating a lot of that longer term archive into this network to reduce some of the costs for our customers overall. Bring as many people as you can. There's so many aspects to the program. There's the sales, there's the marketing, there's the tech piece, right? You still need someone to have the vision for the organization.
The right guys are here. The actual architects are here. The actual end users are here. So there's a lot of interaction and participation within the program. If you want to understand this technology, if you want to understand how you would fit in this technology, if you want to understand the challenges of this technology, then this conference, this ESPA program is perfect. You're not able to only articulate your challenges and what you want to understand. You're listening to real end users who are on the network, who are using this equipment and have gone through a lot of these challenges. On the other side, you got the actual architects of the network, of Filecoin. Session's very interactive. So if there is something missing, we can go ahead and interact and, ask the question, and then that'll probably help the next session.
There's so much more to it, especially if you have to go into a big scale. You probably also need investors. There's a lot around, what is your business model, how you're gonna make money, how you, work around having a crypto native company. It's cool that we're both having the really technical side, but then also covering all the non-technical parts of being a storage provider.
We want to make Filecoin a verb, right? We want to Google it. I want to Filecoin it. Maybe not as smooth.
All right, so thank you for playing that. So some exciting updates and insights from people that actually were there at the Accelerate program last week. Sorry for the way it was presented, the bars and so on. We'll definitely do a redo in the next break. Let's see, who do we have next? Is our next presenter online, please?
If it's me, I'm here.
Oh, Shadi. All right. I was actually looking for Jean-Paul. Don't see him. So, yeah, but let's start with Shadi then. Give me 1 second. Maybe you can share your screen.
Yeah, just give me 1 sec, please.
No worries. So we'll be skipping the public data set. We're running a little bit tight on schedule. We'll start. So Shadi Aldamati is trained as a neuroscientist and an advocate for open science. He founded Upshy as a non-profit organization to support the establishment of public commons for science. And today he's working on tools for knowledge engineering to supercharge today's spirit of discovery and innovation. Wow, what a title. All right, thank you so much for joining us and educate us on how you've used Filecoin, and looking forward to hear more.
Yeah, absolutely. Thanks for having me. I'm super excited to be here today to share some of the work we've been doing with OpSci. My journey with OpSci started off actually very much in parallel with some of the problems and solutions that are being developed by Protocol Labs, specifically through IPFS and Filecoin. And one of these issues really has to do with how do we communicate scientific data in an effective way, and how do we work collaboratively and build collaboratively on scientific data in a public commons in a way that captures the value of science in a way that benefits the researchers and those that use that data to produce the insights and discoveries that power society today. So I want to talk a little bit today about kind of our motivation for why we went down this road and why Filecoin is really important for us to achieve these goals. And the problem that we're really addressing and hoping to solve here are broken feedback loops of value flows in research and development. And so, you know, when we think of decentralization and we think of research, it started off as decentralized, right? I mean, science really was something that happened in the garages or the sheds or the private labs of gentlemen scientists, like for example in the 1660s with the advent of the Royal Society. It was just a bunch of dudes gathering around and talking about philosophical ideas and coming up with different problems that they wanted to address or to solve. And so fast forward to today, and now we have a preponderance of information that's available. And you have examples like the Brain Hack community, which are truly decentralized communities, right? They're all over the world. They run these global type hackathons every couple months. And there's an active energy or kind of a passion to build solutions that benefit the community. And what we're seeing actually is kind of a transition from of expertise and training and kind of really innovative potential transitioning away from siloed institutions and into these communities where all the raw ideas are kind of bubbling together and new solutions are being put together by interdisciplinary teams. And so, somewhere along the way between 1660 and today, something kind of went wrong, right? Where we've started having an increased consolidation of the value that science produces within these institutions. And a lot of it was necessary for us to execute national strategic priorities, whether it's the Manhattan Project or whether it's vaccine development. However, if you do look at economic growth and development, it is related to basic science research output. And this is something you can actually quantitatively measure. It's called the Solo residual. If you take an exponential curve and fit it to GDP growth over the last century, you'll find that there's some things that you can't explain away with just your common economic metrics, right? And so basic science is thought to be one of those remaining sources of variance that explain away the residual behind economic growth. However, today we have this pretty big problem where public funding goes to scientists, and this public funding is usually powered by taxpayers from individuals or businesses. And the value that's created by scientists often ends up getting siloed into knowledge curators. And knowledge curators not only use scientists as free labor to peer review, to sit on editorial boards, to actually produce the knowledge, they also charge them to publish papers, open access, for example. And then on the other side of the bill, they're also charging commercial research and development teams to access this knowledge. So you're having this appropriability issue where the value of science isn't being fed forward into a feedback cycle, but to fund more science, but rather is coming into those that are curating knowledge and accessing knowledge and determining what the terms of the paywall of the paywall should be. So you can see a really good example of this with kind of contrasting Elsevier, which is just one of the major publishers out there, against the entire University of California system. So if you look at all of the patents, all of the intellectual property that the UC system, this includes UC San Diego, UC Irvine, UCSF, UC LA, and so on and so forth, huge institutions that have produced many, many different life-saving drugs, therapies, patents for space exploration, so on and so forth. In 2016, they were able only to turn over 22% profit margin. So that's about $48 million for them over all of their intellectual property due to royalties or licensing and that sort of thing. However, the same journals that these scientists are publishing in, right, are turning over a 37% profit margin for almost $750 million a year later. So there's something definitely wrong here. And this brings us to the question, well, how do we grow a self-sustaining knowledge creation community that's as prosperous as it is productive? And a solution to this problem, and I think Filecoin, as well as distributed file storage and cloud service technologies, are really at the heart of it. And the approach that we're taking, which I call data kintsugi, which I'm not sure if it's a novel term or not, but it's this term that's taking the art of something broken and putting it back together to make it beautiful again. So if we look at the scientific ecosystem today, we'll see that there's this unstructured, chaotic corpus of data that's short-lived, that sometimes falls off the map, and is distributed in a bunch of different silos that are locked away due to either regulatory concerns or compatibility issues, whether, even if you did have access to it, would you actually be able to use it? And this is really what motivated me as a neuroscientist, because I worked in a magnetic resonance imaging center, had access to massive amounts of data, and wanted to collaborate with others in other continents or other countries, and it was very, very difficult to do so. So can we take this unstructured corpus and build out a data layer for science, or an interoperable federation for a data commons for science? So we've been doing just that over the past 6 months. Ever since starting to work together with Protocol Labs and Filecoin and getting feedback on our solutions. And this is the solution that we've come up with so far. So we've identified a Web2 corpus of neuroimaging data. It's over 260 terabytes. And this data is indexed by a metadata aggregator that's really kind of common in the field, or at least in my specific field, for aggregating this data, indexing it, and telling you where those remote sources are. And so we've begun crawling that metadata aggregator's indices and starting to push that data off into Filecoin and decentralized file storage. We're just wrapping up our piloting experiment. This was done in collaboration with Textile using some of their BidBots and the PowerGate CLI specifically. And we've put together a pipeline that could really be easily adapted to different other extra pipelines, for example, like through Estuary. This is what we're converging on now, where we want to scale this pipeline up to start archiving the majority of this data set. So the idea is that we have this public data commons that's being archived from these Web2 corpuses that might have transient data. And what we've realized actually in the process of this is data that we've been actively indexing is actually falling off the map as we're indexing it. And it's coming to be that some of the data that we're storing actually only exists on Filecoin now, or would only exist on Filecoin if we got to it fast enough. And so our public data commons is running on Estuary on the back end, which allows us to pin data to IPFS for data routing. So individuals can grab the data, it'll be pinned there. If they're running their own IPFS node, they can also continue to pin the data. And this really opens the door for a federation of decentralized peer-to-peer data sharing for science. Our vision is, once we've scaled this up and proven it out, that individual research labs that do have extra compute hardware or extra storage hardware would be able to run their own Estuary nodes and be able to join the network as a node. And so we have these research labs, they're sharing their data, and research labs generally want to be able to allow others to work with their data sets. And so the ability to provide views on top of that data through science web apps for unaffiliated researchers will be an absolute game changer by unlocking these silos for data. So how does this data layer really kind of look like under the hood? Well, we're kind of thinking of data sets actually as an abstractions of data tokens or synthetic assets, where we can control, or not even control, but rather provide role-based access control through identity frameworks, for example, like ENS, or identity aggregation using attestations using public-private key cryptography, whether it's using an Ethereum key or a GPG key. We're actively exploring that DeSci identity or decentralized science identity directory to act as a role-based access control for these data sets, which would allow us to kind of get around some of these other issues regarding permissions and sharing. And we're looking at Ceramic as a way of constructing schemas that are configurable and forkable for other people to use and adapt as they see. So everything we're building is open source, and it's available for other people to build on and version in the way that fits their use case. And we're looking at IPFS as our distribution, and it should be obvious to the audience here, we're looking at Filecoin and also ARWeave as archival for certain types of data sets. So once we have this data layer, we can kind of bring in this application layer to begin operating on the data and providing new views. So once this is integrated with identity, once we have these pieces working together, then we can start looking at things like permissionless journals that are automated on chain, that allow anybody with a pseudonymous DeSci, decentralized science identity, to submit a paper, right? Or to be a peer reviewer. We can also think of things like compute markets, where individuals can upload data sets or provide cloud services and perhaps monetize those for other individuals to come in and utilize those services for their purposes. And then other potentials are, for example, data lockers, right? So for example, as a scientist, I need to be able to archive my data, but perhaps I don't want to publish it to a compute market, and Filecoin makes that possible through some of their programs like Filecoin Plus. And the end goal really here is to build applications that really serve us in meat space in the reality layer, where we're bringing networks of labs closer together to foster new forms of collaboration and to make it possible for data sets that otherwise couldn't move or otherwise couldn't be operated on unless you had some very special privileges to finally make it out there and really kind of push forward innovation with big data and science. So coming back to the appropriability question, how are we going to solve this with a data layer? Well, I think there's a potential solution here that we're crawling towards or inching towards, and we're still discovering things along the way. But the basic schema is this, where we have open access knowledge, and we want to provide a portal for private applied research, but at the same time being able to assess appropriability of that knowledge. So when open access knowledge is used for private applied research, can we start thinking of public goods taxes or public goods fees that come back into public goods treasury that feed back into open access knowledge that further promote innovation and more private applied research that generates products and services that make our society better? We can dive into this a little bit more detail. We can start thinking of things like a regenerative data commons, right? For example, where a private researcher might want to access knowledge markets for a particular type of open access data set. Sure, it's open access, it's free to download, but if they want to run a specific type of algorithm or some high intensive job on top of it, that would be something that they would pay to access for compute. And thinking of ways that we can build this into a positive virtuous feedback cycle for open access research. Here's our roadmap, kind of, if you're curious to see where we're going with this. Right now, we're in the midst of user requirements research for neuroscientists, really trying to narrow in and hone in on what they need to make their research work more smoothly, more efficiently, and to be able to innovate more quickly. We're putting together a bench to mesh backend. So this includes that 260 terabytes of open access data, getting that onto Filecoin, as long as with some onboarding materials for institutions so that they could run these nodes on their own. Eventually, we'd like to deploy our knowledge market, which we have a demonstrator on testnet right now, and see whether it's something that could actually be deployed on a federated network of institutional providers. Tons of things to work out there. And later on in the coming years, we'll be looking into demonstrator workflows for compute jobs on distributed cloud service networks that are routed through the knowledge market. And we're hoping to explore a potential token community pilot where we have our DeSci identity solution matched into kind of reputation-based metrics and allowing kind of this community governance of a Web3 science commons where public and private research and development can come together to help promote science. Yeah, so I can give you just like a quick overview of the different types of components of our ecosystem. Our Open Science Knowledge Commons is up on a testnet. More than happy to, if anyone's curious, to answer some questions on that. We published a couple data sets on there, and we're working on integrating natively Filecoin into this. This is built on Ocean Protocol. We've also put together a toolbox called Dark Spice, or Decentralized Autonomous Research Community Simulation Program with Integrated Circuit Elements, toolbox that allows us to perform multi-agent modeling and understand exactly what happens when we tokenize certain data sets or certain commodities, and what sort of stable dynamics emerge in the ecosystem, and what design patterns work and what design patterns don't work. And lastly, we're super excited. Also, we'll probably be releasing this soon, a preprint archival server for researchers that will archive their data permanently on Filecoin and ARweave. And this, we're expecting these different components to be integrated together. If you'd like to learn more about what we're doing, we have more full-length blog posts on all of our tech and all of our progress on pulse.opsci.io. So please do check us out. And thank you so much, Stefan, for the time and space to share our exciting work with everyone. Thank you.
Awesome work. Love how you put more control in the scientists' hands and create tooling around it. Any questions for Shadi? I see some more people coming in. Well, thank you, Shadi, as always. Appreciate it. Great conversation, and we'll see you on the internet. And yeah, we'll hear more from you in the future, I bet, with all the optimizations and the features that you're building. So thank you.
Right on. Thank you so much for the opportunity, Stefan. Take care.
Thank you, Shadi. All right, let's go to our next customer. Sorry, I was on mute. Arkady. Arkady is at the Internet Archive and is joining us today to talk a little bit more about how the Internet Archive has utilized Filecoin. And feel free to share your screen. I know you want to do a little bit of a mix, kind of set the context, right? And even go a little bit more into the details, technical details. You have a little bit more time, actually, Arkady, so take your time and welcome.
Okay, sounds good. Thank you. All right, let me share my screen. Hi, so my name is Arkady Kukarkin, and I'm the Decentralized Tech Lead at Internet Archive. Prior to this, I was at Protocol Labs, as well as leading development on an early foray into decentralized library technology called MediaChain. But today I want to talk to you about what the Internet Archive does and how we are experimenting with using Filecoin to support it. So brief history. So I think many of you have probably seen this page or used the Wayback Machine, but just in case, let's take a look. So in essence, the Wayback Machine lets you travel back in time and look at what a particular web page was like at that time in the history of the internet. And oops, okay, well that capture actually doesn't load. But let's see. There we go. So here's a early capture of the Protocol Labs homepage from our collection. Beautiful. But I would actually like to go even further back than that. And here, all the way from 1996, is our founder, Brewster Kahle, talking about starting the first digital library.
In terms of technology, but also political faults. The Library of Alexandria was burned. Yeah. So we need to be able to preserve our digital history in multiple places under different regimes. So basically, since these things require attending, every 10 years you've got to move it forward to the next generation of technology, or it dies. So you need an organization to keep it going, and I will endow the organization with enough money to keep the bits alive forever. So any bits that are donated to the Internet Archive, I will make sure has the money for every 10 years, will keep it alive. And when it comes time to work with the National Archives or the Library of Congress, they can deal with terabytes, and then we will provide a copy to them. But right now, there are no institutions that are doing large-scale digital collections. And so we're, I think, the first that is starting to build the core collection that can become a digital library, at least of this type of material. And this is all it takes. This is another Sun computer donated by Sun. 20 gigabytes of hard drive space that's used as a cache. So that machine in the other room gathers web pages and puts them in a 100 megabyte chunk, transfers it to this set of disks, and after they've been here for a while, they basically get transferred to tape. And that way we can cost effectively store the whole net, which is estimated as between 1 and 10 terabytes. And that's and growing at what rate? We don't know. We don't know. You know, there's estimates that it's doubling every 7 months, but frankly, we just don't know.
So, of course, the first thing that probably jumps out at you is the sort of the quaint numbers here, you know, double-digit gigabytes and single-digit terabytes as sort of the entire amount of data that you might think about. But the part that I want you to pay attention to is the comment about moving to a new set of technologies every 10 years. And obviously, at this time, it was moving from, you know, single manually handled tapes to tape robots, then to hard drives, to custom racks of drives, and so on. But I think now there's a real possibility that decentralized storage like Filecoin is actually this next 10-year evolutionary step. And so we're looking into it now. And jumping back into the present day, we've just celebrated our 25th anniversary in October, and now we have quite a bit more in our collections than just the net. So, of course, we have the Wayback Machine, which is a substantial fraction of our collections. But we have public domain works, for example, a LibriVox audio collection, which has about 20,000 audio recordings of public domain material. We have specialty collections like the Prelinger Archives, which collects home films and otherwise easily lost material. We have library books that are loaned out just as with any other digital library. We have user uploads. We have a live music collection with hundreds of thousands of recordings and many more. So as you might imagine, running a preservation operation at this scale as a nonprofit presents some unique challenges, especially as pertains to interacting with the Filecoin network. So the first is that we use specialized multi-tenant hardware. For example, here, you can take a look at the Petabox page. We have some interesting compromises, such as no air conditioning, but we have quite significant numbers of nodes, disks, and data stored. So over 60 petabytes on the Wayback Machine, 40 plus petabytes in the books, music, video collections, various unique data is over 100 petabytes and so on. However, these machines are running at essentially full capacity at all times. We also have ever-growing network traffic and associated congestion. So I was actually hoping to show you some real-time stats from that, but I think our stats system is having some trouble. But we can take a look at the, sorry, where is it? We can take a look at the weather map. So this is not a comprehensive view of our network. It's just some slices of it. But as you can see, there are some very fast links and there are some very red links. And here red means that we are consuming the full available bandwidth and router load on that link. There are also, and both of these concerns come from our mission, which is to maintain the data in perpetuity and to make sure that our endowment lasts as long as it can. So it's kind of an efficiency game. We can't over provision things. We have to use the resources to their greatest extent. And this was actually stressed even more than in previous times during the pandemic. We've seen unprecedented traffic growth, and frankly, it's hard to keep up. The people really want access to these materials. Another concern that comes with managing things like library books, which must be loaned under particular terms and for particular lengths, is access control and therefore encryption. So data stored on IPFS or Filecoin, obviously world readable in that context, needs to have certain access controls for certain kinds of content. And finally, we have concerns around takedown requests. So some of the data that we ingest may end up not being compliant with particular regulations or laws. So we need to be able to take down that data rather than just sort of letting it roam free. And we are also faced with the same network challenges as other users. So miner reputation has been a big challenge. I know there is good work in this space, but it's still early days. We still see faults with some miners, and we'll talk about how we manage those in a minute. And we also are restricted somewhat in our miner selection because all our deals are based on data cap. So let's talk about the work so far. So the collection that we've chosen for our exploration is the what's known as the end of term crawl. So here is the sort of typical interface for it. It looks a little bit boring, but what it is essentially is a complete capture of all US government websites at the moment, or rather before the moment of the inauguration, and then after the inauguration, in this case in 2016. And here you can see an archived page from that set presented in our normal Wayback interface. It takes a second to load, which is also important later. Actually, here's one I loaded earlier. So here's the FBI office from Indianapolis. So these pages comprise about 200 TB bytes altogether, and they are presented as items within our collections, much like this. And you will notice here that we actually have an CID listed for the item in view already. So it's 200 TB bytes overall, about 10 GB per what we call an item, which is the basic unit of organization within the collections. And within that are 1 GB files, which are essentially recordings of web crawls. And we're replicating this at 3x, so we're looking at about 600 TB bytes. And the way that we've been running this is using our own S-Series instance. And here is a view, and we've actually just recently migrated to a new machine without having imported the previous deals into this. But you can basically see what it looks like here. Here is one item. Here we have some sealed deals. We had some deals that faulted recently, so these are sealing, and we have another ongoing transfer. The items look pretty good through the IPFS interface. It's all the same files as you could see in our normal viewer. And the really cool thing about this is that we can actually access some of these web crawl records directly using a static application like replayweb.page. So here's an example capture. It doesn't look very pretty, but it is loaded from IPFS, including the viewer, which is a static JavaScript application. So we're also working with other collections like the LibriVox collection, which presents different challenges. So these are smaller items. So this is only about a couple of hundred megs altogether. And so here we're faced with challenges like aggregation and addressing these smaller items within the overall sets. Oh, actually, sorry, I need to refresh this. Okay. And at the moment, our bulk ingestion is actually paused because we are pushing on certain solutions. As I mentioned before, we have unique challenges due to our particular infrastructural choices necessitated by our mission. As I mentioned previously, the petaboxes, the petaboxes are quite powerful machines, but these are extremely high tenancy machines that are running all sorts of tasks for the archive. So we're not actually able to allocate the type of machine that would typically be used to service an estuary node or even Lotus node to run things in a sort of centralized fashion. So what we've done to address some of these challenges so far is parallelizing the car file generation and comp calculation using our cluster system. This is done with a custom Docker image, which you can see here. It's again not very sexy, but here is a run from the cluster for the item that you're looking at now, and you can see the files being packed and placed in a car file. We then currently transfer the car files directly to a sort of single point of failure estuary instance, but we are still constrained on network traffic and route overload on an individual instance basis. So that's why the next thing that we're working on is parallelizing the transfers as well. We're collaborating with the estuary team to make the shuttles, which are essentially sort of secondary nodes for estuary. We're working on making them ephemeral so they can also run as tasks within our cluster rather than demanding their own permanent machine commitment. We're also considering shipping disks. This is, of course, the cutting the Gordian knot solution that I think many miners prefer, but we do think that the disk shipping method is a little bit of a trade-off against decentralization and the use of the protocol that we're all committed to. So it's a little bit of a trade-off. Another thing that we're involved in pretty heavily is user advocacy, user education policy and advocacy. The Internet Archive has an affiliated group called DWeb, which now is kind of a generic term, but when we started it in 2016, it wasn't quite in such wide use. And this is essentially decentralized network of nodes that host events, discussions, and promote advocacy and policy in the space. We're an example of the edge user education efforts is a talk I gave just the other week to an association of librarians for the Metropolitan New York Library Council. There's a video link here. It's probably not as of such interest to the audience here, but it is quite useful for those not familiar with the technologies. We're also partnering with Unfinished Network and many other organizations. So what's next for us? Well, first of all, we really need high quality miners that work with our particular requirements. And I know we're already in touch with some of you in the audience, but please reach out and we will add you to the sets and we'll be delighted to work with you. We're also experimenting with other tools like Bitbot and Textile, which is currently a little bit constrained again by our network concerns, but is certainly being worked upon. But the things that we really need are fast and partial retrievals. So the transfer of items in currently about 10 gigabytes, so third of a sector size, is something that is great for an archival use case, but what we're really interested in the long term is sort of a Web3 app or direct retrieval by patrons without going through our servers necessarily. We also need encryption, access control, and immutable collections to accommodate some of the needs of the collections I mentioned earlier, such as library books and takedown requests. We're also developing a approach for onboarding collections on behalf of other institutions. For example, the Prelinger collection that I mentioned earlier will probably be uploaded in the coming months through the infrastructure that we're building. And I'd also like to just shameless plug here and say that we're hiring another decentralization engineer. So if you know someone who would like to work in this space, please let us know. Okay.
Awesome. Well, that was amazing, Arkady. I learned a few things, and I love how you walked us through the whole workflow. You kind of, for those who don't know Estuary, it's look it up. Estuary.tech is a tool, an onboarding platform that helps customers with moving large data sets into Filecoin. Thank you. I love that you kind of show the context and actually went a little deeper into the technology. All right. Well, if for anyone, I don't know if there's any questions. I don't see any questions in the chat, but thank you again, as always. And we'll move on to the next presenter.
Thank you.
All right. Who do we got next? UCS. The next presenter is Sam Gustman, CTO at USC Showa Foundation, and Associate Dean of USC Libraries. So welcome.
Hi, everybody. I'm going to share my screen as we talk, but I'm Sam Gustman, CTO of the USC Showa Foundation, and want to make sure you can see all the tabs of my screen. I'll be moving around a couple of different things here. Well, let me start with the slides. So Showa is the Hebrew word for the Holocaust. We are an organization that was founded by Steven Spielberg after the movie Schindler's List, which was in 1993. And then in 1994, we began collecting interviews around the world. We actually opened up in 56 countries, ended up collecting 52,000 interviews from 1994 through 2000. Recording as many Holocaust survivor witnesses as possible. And that's the data is 25 petabytes uncompressed, but compressed it's 6 petabytes of content. We collected in 44 languages. And then in 94, the first web was coming out. And so our goal was to make every minute of video searchable like it was a web page. And I can show you a little bit about what that looks like by keywords, people's names, latitude and longitude, images, etc. And then in 2006, as we became more and more about education and following our mission to develop empathy, understanding, and respect through testimony, we're in half the high schools in the United States with our tolerance education programs. We're all over the world with access, and we were gifted to the University of Southern California, and USC was super interested in bringing in very large digital collections that were of interest to the faculty and community there. And one of the things they did when they brought us in was they expanded us to looking not just at the Holocaust, but other genocides. And we're on our 14th mass atrocity. As we know, hate is sort of growing in our world. And so there's no limit to the number of collections that of survivors who want to tell their stories that we're able to get and the lessons to learn from them. So going to the next slide here, let me just talk a little bit about the life of a testimony. And again, we're a use case for loading up the Filecoin. I'll tell you about where we are on that in a moment. But what happens is the tapes will come in, and we actually not only do new interviews, we will go to museums and other folks and deal with interviews they have to bring them in to get them cataloged and preserved. And the reason we do that is because everything rots. The conservative numbers are you get 50 years for film before you see age-based rot, 20 years on videotape, 5 years on hard drive, 3 years on LTO, 2 years optical. The newer the tech, unfortunately, the faster it's been rotting. And so that's been an issue for many organizations. So we help organizations get their older tapes and other media that they may have interviews digitized and preserved and cataloged for use at schools and other places, as well as collecting new interviews. So we do the preparation, the digitization. We do all kinds of quality control because video is a very manual, mechanical process, and all kinds of different things can occur. We restore as needed. And then we catalog and index, again, making every minute searchable like it's its own web page. We have Visual History Archive as sort of our middleware that we do lots of different user interfaces to our customer base, which are teachers and educators, scholars and researchers around the world, communities of users, people who are, second generation, third generation from survivors of the Armenian genocide, Holocaust, and other genocide collections that we have. And then we get into digital preservation, which is making sure the bits stay around. Before I go into the preservation part, which is where we are leveraging Filecoin, let me just talk about the size again. So it's 116,000 hours, searchable by almost 70,000 keywords. We also have a very sizable image database of images that are shown during the video that allow you to search into the video and names of people, which helps a lot with various genealogy efforts, as well as survivors, getting them back together and helping people find family that they may have lost. So the top level concept around preservation that we use is one called a supertext. It was coined by Steve Sample, who was a president of USC a few presidents ago. And the basic concept is that we've had reading and writing for 5,000 years. So we've had content like Shakespeare, Cicero, the Quran, the Bible, the Torah, that have made it through hundreds or thousands of years. And the question is, what do you have to do with moving images to allow them the same opportunity to become a supertext that makes it through time, especially since we've only had moving images for a little over 140 years. And there are no image supertexts yet because there haven't been images, moving images around that long. So that's our, with all of these testimonies, we want to give them a chance to make it through time with the lessons that they teach. And that is our challenge when it comes to preservation. How do we give audiovisual material a chance to become a supertext? So we've developed a bit level preservation continuum, where on one side of the continuum, we use the internet, which has a lot of geographic distribution and uses a lot of electricity to store and preserve the actual content. And we have a project that we've started with Stanford called the Starling Labs. I'm sure you guys have heard some of those things about that labs. It's been a wonderful partnership for us. And so that is using blockchain and Filecoin specifically to attempt to store and preserve testimony. Then we have things that we've been doing for many, many, many years, where we have data centers filled with tape robots in different places around the world, East Coast, West Coast, Europe. We've also added cloud data centers, so Microsoft Azure, AWS, synchronizing the fixity, checking the health of the video files in those environments and updating them as different pieces of content rot or get out of sync over time. And that is our current solution that we have in place. We are on the research level with Filecoin now, and things are moving forward. And then on the other side of the medium, we're looking at things that actually could hold audiovisual content for a very long time, like DNA, stone, various forms of glass. And when you get there, there's a couple different things. You worry about the reader that gets used for storing these content long time, like on glass or silica or these see-through media, you can use a microscope to read the data. But with DNA or stone, you have a different technology. You need to be able to read the bits of information off of them. And it's not clear how that will make it through time. Although, since we are made of DNA, We assume there will be readers and writers of DNA moving into the future. And so that feels like a pretty safe bet, but that is also in the research area. But basically, our idea is to allow audiovisual material to be a supertext. You diversify in each of these different areas and across all of these areas as much as possible to let the content make its way through time. So from a data center point of view, we currently have for the Showa Foundation a 6 petabyte database. We actually at USC have used the Showa Foundation architecture in the libraries to bring in all kinds of different collections that don't necessarily have to do with genocide either, and have turned it into a cloud archive for academic collections. We have 65 petabytes of data managed there. The Showa Foundation is a piece of that. And then we do the bit level fixity, meaning every 6 months at a minimum, we're checking each and every file, making sure, and that's nothing compared to what you see on the Filecoin network, but it's what we've done to date in the tape data centers. And then, migrating off to brand new media at a minimum every 3 years, keeping various copies around the world. And then what we're adding is hopefully soon a Filecoin copy that can be synchronized with our Microsoft Azure copies and our data center copies to, again, continue to allow the content to move through time in its entirety and unchanged. So I briefly mentioned before Starling, which is a framework for preservation, both us actually capturing, storing, and verifying the content that we're working on with Stanford Engineering. And I want to do a special shout out and thanks to PiKNiK, who's been working with Starling and us for onboarding the Showa Foundation data. We're hoping to have all of the petabytes of the Showa Foundation content uploaded into Filecoin end of May. All the hard drives have been shipped to PiKNiK, who's the miner who's doing the uploading for us. So thank you.
Awesome.
And
sorry, I thought it was your last slide, Sam. Go
no,
ahead.
I'm going slow. Do you need me to go faster? I'm happy to go faster.
No, it's great. It's great. Go ahead.
I got a bunch of slides and a few things to show you. Tell me when you want me to stop, because I can keep talking otherwise.
No, you have more time. Go ahead.
Okay, great. So I just was going to show this. And then again, thank you to Protocol Labs and the Filecoin Foundation for supporting this initial foray of ours into blockchain and putting our content up there. We do have the content indexed down by the minute. I thought I would quickly show if I could here, just a quick example. So you can go in, this is a simple search engine that we have. You can go in and you can either search by experience groups, which are various genocides, keywords. We have those 66,000 people or places, but I can just start typing in words like food, hiding, Auschwitz. And this is telling me there's 5,000 interviews that mention those 3 concepts. I'm then able to go in and I'm able to see and browse through those 5,000 interviews. And if I open up one of these interviews, what you'll see are the minutes of video where those topics are talked about, like the index at the back of the book. And what I can do is, let's say that we queried on food hiding in Auschwitz. I might be interested in identity concealment. I would click here. It would jump to the 23rd segment of this interview. And you'd be able to start watching and seeing from the keywords there. And I can now move around this interview minute by minute and jump around to the various topics. Again, our goal was to have every minute searchable like it was a web page. There are various ways to now move through the content. You can move through by all the people mentioned. To every minute in the interview, you can move through by the indexing terms. Again, this is like an index at the back of a book here, and you can move minute by topic. You can go to a transcript and you can search on, words that you were interested in, and it'll tell you what time frame they are in the video, and it'll jump to that moment if you would like. You can also move around by images. If there's any pictures or images in the archive, you can go there and click on the image, and it'll jump to the moment in the video where that image is shown.
He is Mark's son, and he is 8 months old.
So we do this for, again, not just Holocaust survivors, but on the left here, you'll see all of the various genocides that we've been collecting content and making the content available for. I'm going to switch back now. And this is the cataloging. And so then we have a number of different ways of accessing the material. Eyewitnesses are grades 4 through 12 access learning management system with lots of activities, hundreds built by us and thousands built by teachers to be able to move through the content and learn from it. We have for researchers, the Visual History Archive. We have our website, which is a general tool for all the communities at large. We have some publicly available content through YouTube and other places. And then we've been doing different kinds of testimonies where we've been adding an interactive nature, basically combining what you get from an Alexa with a testimony so you can have a conversation with the testimonies and the survivors. And we've been shooting those interviews in 3D as well as 2D so that you can have those in museums and have a more personal experience with the survivor not actually being there through their AI. So that's it. I thought I'll take a stop there and take any questions people have. Like I said, for us, we're just starting out. We've been working, we've been working for a year, but we've been doing our research and working with PiKNiK and other groups, and we think by the middle of this year we'll be uploaded and ready to begin integrating Filecoin into our preservation infrastructure.
Awesome. That's fantastic. Thank you for walking us through this. Definitely interesting to see all the technologies that you looked at over the last couple of years. And you're right, it's hard. You have all these different storage technologies, right? They all have their own challenges. So working with a decentralized platform that is agnostic, I can see a future where even other storage architectures or storage technologies like even DNA storage could fit in our stack. But cool, thank you so much, Sam. As always, a pleasure to have you. And we'll move on to the next presenter. So we have another customer that you're very familiar with, obviously, Jonathan Doughton, who's going to talk a little bit more about decentralized storage, why decentralization is important, and how Filecoin fits in that picture. Thank you, Sam, and welcome, Jonathan. The floor is yours.
Thanks so much, Stefan. Give me 1 second, and I'm going to add my screen.
That background is very relaxing, very zen.
Can everyone see my screen okay?
Perfect.
All right, great. Wonderful. Well, thank you so much for having me here, and I'm really excited to support ESPA. I think this is an important moment in the creation of this ecosystem, because now we're really thinking about ways in which the storage providers are going to be able to scale. And as you scale, I want to talk to you a little bit today about how to keep some of the principles of decentralization that got us here in the first place to scale alongside all of this. And I was asked to cover essentially some of the legal dimensions about how this might work. And I'm going to make this presentation to you today in thinking about the underlying legal questions by looking at essentially some key parts of the regulation. I'll get into some applied use cases and some history, and then think about basically the future of how we might continue to think about decentralization as it applies to our business. So just a little bit about the Starling Lab. Sam Gussman has been a dear friend and I'd say co-conspirator with me. Years ago, we got to thinking about how we could take the USC Showa Foundation's incredible and important collection of testimony and put it onto the decentralized web. And very fearlessly, he has been working with us in thinking about all sorts of different technologies that could help this effort. And of course, with Protocol Labs and a whole cohort of other individuals, we've been able to make great progress on storing that information, I should mention as a small plug that there are ways for all of you to get directly involved and store a piece of the archive. And so PiKNiK has been key in getting us the sealing done, but now with the the CAR files generated, but now that the CAR files are there, we want to distribute them to others and maintain our decentralized infrastructure. So, so please feel free to reach out and be in touch, because we'd be very happy to work together with many of you. All right, so let's cover today briefly what we're going to discuss. So the first is I want to explain to you a little bit about how the laws and regulatory agencies think about decentralization and really why it's so important. I'm then go into the history about how decentralization came around as an architecture. And finally, let's talk about the future and how decentralization can specifically be a strategy that you can implement as part of your journey as a storage provider. So let's talk about this term, sufficiently decentralized. This was a phrase that was introduced by Bill Hinman, who was the director of the enforcement side of the SEC, and the Division of Corporate Finance at the SEC. This was presented as basically a framework which explained how the SEC was going to consider the regulation of the crypto industry. And this is the long phrase in which essentially he was trying to explain when a token moves from being a security or an investment contract to being a utility, or something which is, by being sufficiently decentralized, is no longer an investment contract. So let's parse this phrase. Let's make it a little bit easier. So the first thing is that it talks about how you need to ensure that the network has, that the essential managerial or entrepreneurial efforts of the network are not expected to be created by a single person or a single group. The second step to being sufficiently decentralized is that by decentralizing, you lower material information asymmetries. Essentially, it means that things become more transparent. And then finally, if you add all this up, what that means is that the participants in that network essentially become interoperable in their role, where it becomes impossible to determine who actually is an issuer or promoter or a user of the network. And that means that essentially everyone is a stakeholder in the success of the network. It's not centralized into one entity, but it is sufficiently decentralized to a network of participants. Okay, so what does all this mean? It really means that decentralization is a key metric that is used by the SEC to determine whether or not a network is actually something which is legally considered a utility and not a security, which is really important, of course, to the viability of any of these types of technologies. So one might think of, therefore, decentralization as a goal. Other projects in the space who might be a little bit more mercenary about this, they might think of it as like a hack, essentially. Oh yeah, I want to float a token, I want to sufficiently decentralize, and then be on my way and evade regulation. I like to look at it a little bit differently. I think about this as an opportunity. And it's both a financial opportunity, which I think is why many of you are here, but I also want to give you some perspective because it's also a historic opportunity, which, if you really get down to the values of many of the reasons why Web3 actually needs to exist right now at this moment in time, this historic moment to decentralize the internet is one that should not be taken for granted. So why is that? Well, I think the main reason is that we're seeing signals from enterprise users and from consumers. On the enterprise side, we're already looking at hybrid cloud solutions as something that is an essential piece of a deployment, because people understand that they don't want to necessarily be beholden to cloud cartels who can extort, especially with egress out of their system. It becomes very difficult. Of course, they kind of lock you in. Well, hybrid solutions allow you to deploy on-prem and also in the cloud. Well, the block cloud, you can think of this as an evolution of the signals of the hybrid cloud solution, because it really allows you to maintain the maximum amount of agency and flexibility and interoperability without being beholden to a single network or necessarily being stuck with having to host this on your own. The numbers, of course, bear this out, that this is not necessarily an easy task. We know that obviously the top 5 providers of cloud storage are controlled by 80% of the market. So there clearly is a lot of work to do in achieving decentralization. But there are movements afoot, right? If you think about it at the high level, there is work that's being done with lawmakers to try to level the playing field so that cloud providers can actually compete. And then there's also this general understanding from consumers that the internet as we know it today might not necessarily be fair. It might not necessarily be the way that we want it to be for the future. And so I want to give you a sense of essentially how we got here. How is it that we have this market that's completely dominated by such a few set of incumbents? So let's talk about the history. Well, I think probably the way to think about this is to think of the crypto era as one that began in the 2010s. And if you go back, like really, you see that then each of the eras of the internet or the personal computing revolution they started off with a dramatic expansion. And each one of these major companies came up as a small company, relatively speaking, and one that was challenging the status quo. And then over time, basically there was consolidation and then commoditization, right? And that's basically led to the revolutions of like microprocessors or the web or, personal computing, et cetera. So what that means is that the cycles of decentralization very quickly move back to centralization and then need to be challenged again. This is kind of this idea that this is almost this repeating view of history. But I want to argue to you that that's not necessarily how this was all intended to be. If you go back to actually the very beginning of the computing revolution and you look at personal computers, which this here was considered in the late 50s a personal computer. And mind you, what you see there on the right-hand side that the gentleman is adjusting, that's actually just the screen and the keyboard. The computer itself is actually to the left. It's that giant refrigerator-sized mainframe. And what the early inventors of the personal computing revolution had to dream was that this massive machine would be something that could be miniaturized with small enough microprocessors. It's one that could have sufficient storage to store complex algorithms, and that there could be connectivity between all these different devices. And this was what Doug Engelbart and the folks over at the Augment Intelligence Lab at Stanford conceived of as the Augment framework, which meant that at the core of the network, what you really had was a personal computer, and it was those personal computers that were then put into a network of knowledge that was decentralized. That means that at the beginning of the internet, the proto-internet, way before it was even called the internet, the idea was that you wanted to have a decentralized network. So what Engelbart did is he created a framework. They then worked to productize this and create things like the mouse and the screen and really give shape to the personal computer as we've come to understand it. And Engelbart, who I view as one of really the history, the leaders and the heroes of the 20th century, isn't often known. I didn't know about him for years because a lot of his technologies really at an academic level stayed as academic paradigms and inventions, but really his students made their way over to a place that most people know in computing history, which is Xerox PARC. And it's there that Xerox PARC was able to take a lot of those key ideas that came out of the Augment Intelligence framework and the whole notion of decentralization and build the key protocols that we know of today across the various application layers of personal computing and the internet, right? So it's important, therefore, to remember that the world we've inherited today has this historical basis, and it has a software code. It's also got a set of principles that one might think of as a moral code, and that's what I like to call the internet code. And at its core, the internet code was preaching or advocating this idea of decentralization. The idea that you'd have neutrality within networks and interoperability, which would then give maximum amount of agency to individual users. So let's move away from the philosophy here and really think about it at an engineering level. Those key ideas, the software code and the principles, actually made their way into the network design. Because if you think about it, really what the invention of the internet does is it took us away from centralized networks of, let's say, like AT&T with its centralized form of routing, where essentially information came into a central node and then came out of a central node to reach its destination. Well, the distributed system, it allowed you to create nodes that passed information randomly. Any of those nodes could be replaced, and that the instructions from getting from A to B did not reside in the network, but instead they resided in the block itself, or what was called the packet of information. And that means that, therefore, the intelligence of the network is at the endpoints. It's not in the network itself. And that means that the users could, therefore, retain the intelligence and retain the agency. Well, that's not really how it all worked out. And why we're here is because we're realizing that we need to create an alternative to what happened, which was that the revolution of personal computing ultimately, when it scaled with the internet, started consolidating into these platforms that emerged as smarter. And so that's really where you get all of the monopolies that have come into the world as we know it today and dominated it and really consolidated storage, consolidated networking, consolidated user applications and intelligence. And they are the most valuable companies in the world today. But think about it. The original web, Tim Berners-Lee's first server on the World Wide Web, it wasn't a mainframe. It wasn't meant to be run by a corporation. It was a personal computer. It was, in this case, a Next personal computer. And I think that's a really important symbol for what we are trying to do. Because as you guys are working on trying to create scalable, decentralized architecture, remember, you're not just aiming to create a new monopoly, you're aiming to actually help reinforce this idea of a decentralized network. So if we add it all together, then we not only have an opportunity to create a new paradigm of technology, but one would argue from the philosophy of the early internet days, you can also have a way of being able to think about new business models. And to quote Stuart Brand, who was one of the early leaders in the space, he put out something that I think is quite interesting and somewhat controversial. So let's read it. It says, our generation proved in cyberspace that where self-reliance leads, basically personal agency, resilience follows. I think we all agree on that, right? Decentralization of information can yield resilience. And then listen to this. And where generosity leads, prosperity follows. That's an interesting idea. Well, let's unpack it. Really, the idea that Brand was putting out there was that if you look into the future and how decentralization applies to you, you need to think about how you're part of a community. And you need to think about how if you contribute to that community, all ships might rise in that community. And this isn't, I want to be clear, this isn't some form of dressed up socialism or communism. This is a pure market activity. And this is capitalism at its core because it's leading to a form of self-reliance and to a form of more resilient network adoption. So let me walk you through what that looks like. Basically, we all know that the traditional ideas of growing networks rely on network effects that allow you to scale the number of users. And as you scale the number of users, the network essentially becomes more valuable, right? That's how we think about networks today. With cryptographic tokens, what you do is you don't just simply focus on increasing the number of users or the utility, but you create incentives. And the idea behind that is that as you bootstrap networks with Web3, you use these block rewards that you get in order to drive adoption, in order to build utility, right? And then over time, the tokens essentially become normalized and they become part of the underpinning of the long-term economics of the network. And so really, therefore, what you're banking on is that what we're doing here in Web3 is that we're creating new business models and essentially a new corporate form. And what that means is that as you think about sufficient decentralization and being part of this community, here are some ideas that might make a lot of sense in the long term and the short term. One is that transparency is a really important principle. If we're going to decentralize and we want to actually bring together this community, information asymmetry, where essentially you somehow put others at a disadvantage, that's actually not a sustainable business model. And that, by the way, includes information asymmetry between you as a storage provider and the end users whose data you store. You want to be transparent about how much you're making and what is the sustainability of your infrastructure. The second is that you want to collaborate, and that creating vertical integration and lock-ins, those things might work in the near term, but in the long term, that's actually going to destroy the network. And ultimately, we'll just get right back to where we were with consolidation. So really think about why programs like this make sense. It's because we're trying to create viable infrastructure that we can all maintain for the long term. And finally, when you do that, you understand that therefore, by bringing in a variety of stakeholders, meaning other storage providers and users of the network, that allows you to maintain the value of the token and for it ultimately to go up over a period of time where there is a virtuous cycle as the users become the stakeholders of the network. I want to say this again. if you want this network to succeed, it means that you have to work together. And if you do that, that's how the network appreciates, and that's how it becomes sustainable. That's the new business model. So that means that participation can yield further adoption. The product quality is something that can yield retention. And finally, diversification can yield resistance. That's really the goal of how you think about decentralization. And so all of you are going to be faced with these questions: how you're going to use block rewards to create these types of long-term incentives. Are you going to use it to create utility, to strengthen the network? Are you going to use it to promote innovation? Are you going to use it to support the community? Those are the key questions that I think you have to start to answer as you become successful. And that essentially is the strategy of sufficient decentralization, because it means that you are now looking at the long-term horizon of this opportunity. And I would argue, if you do that, it can become your competitive advantage. So thanks for having me here. I'm happy to take questions, and certainly very happy to engage with the community as it grows.
Wow. Thank you, Jonathan. That was amazing. I'm going to make sure every new member of the community has to go through this. This is an amazing, storytelling, and also I learned a couple of things here that are so core and so key to like what we do on a daily basis. I can't express enough like how well you translated the decentralization benefits and also the strength of the community that we praise, right? That we are living by on a daily basis. So thank you. All right. Does anyone have any questions or comments? Please put them in the chat. See a lot of thank yous there. So again, thank you so much, Jonathan. We definitely want to see that pitch again, or that talk again. Great storytelling.
Great to be here.
Thank you.
Thanks to all.
Okay, let's move on to John Paul Farmer, who has come back and give us a short overview on public data sets. John was the CTO of the New York City, and I'll let him introduce himself, but welcome. Thank you for joining us today. And if you could educate us a little bit on why public data sets have become more, I would say, ubiquitous, and also, what's sort of like the trends that you're seeing in this space, and how Filecoin fits, or decentralized storage fits in this.
Thank you, Stefan. It is great to be here. As you heard, until recently, I was the Chief Technology Officer of New York City. And I want to talk to you a little bit about today about a specific use case where I see a really big opportunity for multiple sectors of society to benefit. And I think that the audience here today should be aware of open data and what that means for Filecoin, IPFS, and the decentralized web in general. So I'm going to share some lessons from New York City that I think are applicable all around the United States and around the world. I'm going to start going back to the 1980s when my favorite movie was Big. I was a kid growing up there. I thought this was so cool. So instead of boring you with X bytes of data created in the last Y years, I'm just going to say there's a lot of data. It's big. And when we think about where that data is stored and who controls it, we often think of corporate power and the amount of data that corporations now have sway over. But there's another important sector that we have to look at, and that's the organizations that work in buildings like this one: governments, public sector agencies, and the really massive amounts of data that they have and increasingly have a responsibility for making open and available. Now, a bunch of the data that governments have is PII, and there's a certain level of sensitivity around that, understandably so, when you're talking about names and addresses and physical attributes and health status, for example. But there's also a lot of other data that's not. Think about longitudinal weather data. That is one of the most valuable things the governments have been making available for a very long time. When you look at the Weather Channel, underlying that is data from the US federal government. Increasingly hyper-local air quality, understanding block by block what the air quality is like so people can take action. Journalists can report the truth, communities can come together, or startups can build entire business models on the data. And of course, there are laws and rules that are always changing. And to be able to track those, trace those, see the evolution of the rules under which we all operate in some ways that strikes me as a fundamental right. And I think there's a real opportunity to make this significantly more accessible through the decentralized web and decentralized storage. And then finally, demographics, community demographics, the existence of equity or inequity is something that people care a lot about, and others care about hiding. And there's an opportunity here to make sure this data is widely available to all who want to know it. So open data is a concept that 20 years ago, people didn't really talk about, but the phrase was coined. And over the course of the last 15 or so years, this has become a movement. And whether you're looking at the efforts of Code for America and Code for All and local brigades in cities all around the world, or you're looking at the Open Government Partnership that was created in 2009 and has member states all around the world, you're looking at a movement that has led governments to default to open, to actually, in many cases, create laws like the one in New York City that Mayor Bloomberg signed in 2013, making data open by default, creating what at the time was viewed as a gold standard for other cities, states, and federal governments to follow. Now, in New York City today, there are roughly 4 billion rows of data. And that comes from thousands and thousands of different data sets. Some of them are maintained throughout time, so you have really longitudinal records, others less so. They can be overwritten. And when you think about why this is occurring, you have to think about the ways in which the data is currently stored and accessed. And in addition to what governments are doing, there's the other side. There's the pull side on the outside. There are communities that have developed to encourage governments to do an increasingly better job at making data available in a way that's usable, in a way that's more granular, more timely. And that's things like open data weeks. Next week in New York City will be another, I don't know if it's the 10th or the 12th open data week, but there've been a bunch of them. And you see this gaining speed in many cities around the world. And when you think about what those cities are using today, there are a few platforms that dominate. Obviously, there are edge cases, but many cities are using Socrata, CCAN, or DCAN. And at the end of the day, underlying that, the storage is occurring on the hyperscale cloud providers that we all know about, Amazon, Microsoft, and Google being the three dominant ones in the United States. Well, that's where Filecoin comes in, because now there's actually an opportunity for a decentralized alternative, for an alternative that disintermediates those hyperscale cloud providers. And especially when you start thinking about where the value generally comes from those large corporations, it's less in the storage and it's more in the tools. It's the tool set that they provide around the data. And when you think about what open data is doing, very little of it is actually around analytics. The job is openness. The job is to fulfill the requirement to default to open so that the people on the outside, those entrepreneurs, those journalists, those historians, whoever they might be, they can choose what to do with it and they can apply whichever tools and analysis they want to. And so now you get into the question of what's the cost benefit for the cities and the governments that are responsible for making the data open, that are currently paying the prices that are essentially dictated to them by a relatively small number of companies with very little competition. Well, now there is competition. And so in New York City last fall, we ran a pilot, started a pilot, still going on, to take several high-value data sets, put them on the Filecoin network, and then test and assess and see what happens and create evidence, real-world evidence that can be shared with New York City and with cities all over about the potential benefits of the Filecoin network. So we focused on these three different types of data: air quality, city demographics, and public hearings, for some of the reasons I mentioned earlier. These are the types of things that people care about and where there's value in ensuring that they are preserved over the long run. The roadmap that Protocol Labs put together of how NYC Open Data integrates with, meets up with the Filecoin ecosystem can be viewed here. I know the type is a little small, but ultimately what we're looking to measure is cost. The estimate is 0.02% of the cost of storage, lower latency, more resilient, and of course, censorship resistance. These are some of the things that could be benefits. And when you really step back and you start thinking about the different types of data that cities and states and federal governments have, I think it's important to recognize that increasingly they themselves, especially because of the rise of artificial intelligence and machine learning, they themselves are starting to ask, should we have a more robust data strategy, or in many cases, a data strategy at all? Should we look at our data resources, given the characteristics that each one has and the needs of the outside community? And are there ways that we can do these things? We can lower costs, we can improve resilience, we can ensure that no matter who comes into power in the future, that data sets that the public has paid for and the public cares about remain open and available. So what we're doing now is measuring, and we're going to measure throughout early 2022, and we're going to work with other governments around the world to run similar pilots and to measure what's possible. And when you think about who could be a customer, I want you to remember that governments are out there, that governments have massive amounts of data. And over the past 10 years, increasingly, they've got laws on the books that require them to make that data open. They don't always fulfill the letter of the law simply because of things like cost. And so if you can solve these problems, you can create a win, not just for the storage providers in the Filecoin ecosystem, but for governments themselves and ultimately for society. So really appreciate being here, appreciate being a part of this conversation, and happy to discuss anything related to public sector and the Filecoin network.
Amazing. Thank you, John Paul. This is basically like a recipe for any storage provider that wants to hunt for data sets, right? So what you're telling us here is that there's a clear trend, clear opportunity, and in most cases also like a budget too that's allocated to this, I would assume. But with Filecoin being so cheap right now, which is basically free, there should be a win-win for both, like you said, the storage provider and the cities.
I think it really should be. And I draw an analogy here to language translation. There are also laws on the books telling governments they have to translate many documents and services in a variety of languages, and they simply don't fulfill that obligation because they literally cannot afford it. They don't have the budget available. So yes, there's a budget, but it's not enough to do everything they're being asked to do. And here, Filecoin has the opportunity to be a solution that actually enables them to fulfill their obligation, their duty. And when you end up working in the public sector, you see that people can be pretty risk averse. But when you can prove to them that you can actually take risk off the table, you can take the potential for a negative story or someone hauling them in front of the legislature to answer questions under oath about why they are not fulfilling their obligation under the law as a civil servant. Suddenly, people's ears perk up, and that's the kind of thing people respond to. So it seems like there's a real opportunity here to measure what's going on right now with the pilots in place, run additional pilots, and ultimately create, I think, a pipeline connecting the Filecoin community with these governments around the world.
Great story. Wow. Cool. Any other questions for John Paul? Anyone, please add them in the chat. No? Okay, well then we'll move forward to the next. Thank you so much, John Paul, and all of this information, all of these videos will be available on YouTube, obviously. So I'm expecting some follow-up after the fact, as we always have a lot of viewers after our live events. So with that, thank you so much for joining. We'll pass it on to our next presenter, Alan Ransel. Last but not least, we'll talk about Filecoin Green, how Filecoin is contributing to a greener world. There we go. Welcome, Alan. And Alan is from Protocol Labs. The floor is yours, Alan. Go ahead.
Awesome. Yeah. Thank you, Stefan. Yeah, really happy to be here and talk about what we're doing at Filecoin Green in order to think more about making the Filecoin network verifiably sustainable. And so, at Filecoin Green, we think a lot about two types of questions, right? So firstly, what can we do to make the Filecoin network itself more sustainable and do that in a way that is publicly verifiable? And then secondly, we think a lot about how can we use Filecoin and Web3 more broadly to upgrade environmental claims. And so, this first question, right? How can we make Filecoin verifiably sustainable? We think about, it's especially relevant to this audience of storage providers. What does it mean for a storage provider to be sustainable or be green? And how can we build tools allowing storage providers to make these really strong sustainability claims and support them to your clients, right? If you're a storage provider and someone is a client storing data with you, how can we build the tools to allow them to see where your energy comes from and allow you to prove that you're doing a good job sourcing renewable energy? Then also, how can we take that information and pass it throughout the ecosystem? So how can we make environmental accounting a Filecoin superpower? How can we make the Filecoin ecosystem somewhere that people seek out our community? Because people know that if you want to do a really good job tracking this type of data, you want to be in Web3. And then that's sort of a bridge into this next set of questions, right? Is can we do for sustainability data what blockchains do for bank records, right? So with blockchains, right, all your transaction data, the inside of everyone's bank account is just public information. Right now, though, most sustainability claims aren't backed by publicly available raw data, right? They tend to be these glossy PDFs you can read, or not so glossy in some cases, PDFs you can read. And they have a bunch of output data that, people have audited it, people have looked at it, but it's lacking that connection, right, to the raw data that actually underpins all of those sustainability claims. So how can we fix that? And how can we use Web3 to fix that? So what does this look like in practice? So I mentioned if you're a storage provider, right, so you consume electricity, you have hardware, maybe there's other inputs that affect your environmental footprint. Those will go into your storage provider operation. You provide storage, right, and clients use that storage. So we're interested in building tools, and some of these tools we build ourselves. Some of them we support others in the ecosystem to build that allow everyone in this value chain to measure what their environmental impact is, right? So can you measure what your environmental footprint is based on your inputs? And then if you're an input to someone else's process, can you pass that information downstream? Then what that also allows you to do, right, this is the vision, is for everyone in this value chain to make decisions that reduce their environmental footprint. And our goal is for the Filecoin network as a whole to be not just net zero, but ideally go past the 0 point on the axis, right, become environmentally beneficial. And so there are three sort of relevant areas especially for enterprise storage providers that we're working on to do this. And so, the first part is how do we take storage providers and connect storage providers in the network to renewable energy markets? The second is how can we leverage all of the resources at our disposal to help build new renewable generation capacity? And the third is how can we improve verifiability of all of these claims? So I'm gonna touch on each of these in the next few minutes. So, first one, connecting storage providers to renewable energy markets. Renewable energy markets themselves are kind of complicated, right? And so the question is, if you're an end user, right, and most storage providers pull energy from power grids, how do you show that you are actually supporting renewable energy, right? Because the power grid is complicated. A bunch of different electricity generators dump energy in the same power grid. A bunch of different people pull energy from that power grid. How do you, match electrons that you're pulling out to electrons that someone else is pushing in? And the industry standard for doing this is called an energy attribute certificate. They're called a lot of different things in different markets. Sometimes they're called renewable energy certificates or guarantees of origin or international renewable energy certificates, IRECs. There are a bunch of different systems, but the idea is that there's a local registry of everyone who is producing renewable energy and selling it in some region. And then you're able, if you use electricity in that same region, to go to that registry and purchase renewable energy directly from someone, right? So you're still pulling energy from the power grid. You don't have to disconnect any wires or whatever, but there's this transaction where you're giving money directly to, say, some solar farm or wind farm and purchasing renewable energy from them that they're putting into the power grid. And so this is the industry standard for making statements like, this product is made with 100% renewable energy. When you see that statement on a product, that means whoever makes it has accounted for their electricity use in, say, their factory, and they've purchased energy attribute certificates corresponding to that energy use. So that's what we're doing for Filecoin. And we're aiming to do this in an extremely transparent way. So firstly, we spent a long time looking at the electricity use of Filecoin storage providers and talked to a lot of them, including PiKNiK. and put this GitHub repo together with our energy use model. If you're interested in this, there's a draft of a academic style paper we published looking at how this model is designed and what all the different parameters are and where these numbers come from. And so what we did is we then put all of that information into a dashboard, which you can find at filecoin.energy. So you can go there now. You can look at the total energy used by the entire Filecoin network, right? So, around 145 megawatts at the moment. You can look at this for individual storage providers. So, say you're interested in this particular storage provider's energy use over the past year. You can look at what the upper bound estimate and lower bound for that storage provider's energy use are. You can export all of this data, and there are APIs allowing you to use this data in products you might build, right? And so we think this is, well, we know this is a huge upgrade relative to most other networks in terms of the transparency of that input, right? Electricity use, which is the major component of most blockchains' environmental footprint. So we're really trying to upgrade the transparency and verifiability of statements about how much electricity is being used in a given ecosystem, specifically demonstrating this with Filecoin. If you're interested, Filecoin, we believe, provides about 0.77% of global data center storage capacity. And this was actually from a month or two ago, so I should double check this. It's probably higher now. And consumes about 0.62% of all of the electricity used by data centers around the world. And that's based on this estimate number. And so we've written about this, happy to answer more questions about this. And we've published a lot on where these numbers come from. But those are the basic benchmarks that you should sort of go to when you think about Filecoin electricity use. So then we're able to take this and map electricity use, right, to individual storage providers, and then map them to energy attribute certificates. And we're working with this ecosystem called Energy Web, and specifically a company called Zero Labs that spun out of Energy Web that we're working really closely with in order to take energy attribute certificates in representing energy generated, renewable energy generated in specific locations, and mapping them to Filecoin storage providers. Right. There are a few places you can track this. One of them is the reputation system. So we added this renewable energy purchased column, right? So this storage provider has purchased 168 megawatt hours of renewable energy. You can go to the Zero Labs website. You can type in the miner ID for a given Filecoin storage provider, and you can then look at how many RECs have they purchased that have actually been redeemed in the registry, and how many RECs or EACs are under contract currently. So a broker has contractually obligated themselves to supply renewable energy to the storage provider. And so you can look at things like, you can look at the actual registry attestation, right? So you can say, okay, I'm going to download this record from Greenie, which certifies renewable electricity purchases in the US, and map this to an individual storage provider, right? So we're really raising the bar as to renewable energy claims, and specifically public verifiability of renewable energy claims, demonstrating this on the Filecoin network. And this is something that we want to build all of these tools in a way that you can plug into them. There's also this really neat map. We just opened a bunch of these APIs, and a community member built a map where you can actually see different storage providers all over the world. Zoom in and look at their, say this, storage provider. You can look at their energy use, and this is pulled again from that API. And so there's a lot going on here. And I'm happy to take more questions on this, and also talk to people who are starting SP operations about how you can plug into this and start making these really strong renewables claims yourself. So secondly, we want to support people to build the new renewable generation capacity, right? It's great to buy renewable energy from a solar farm or a wind farm that's already being set up. You are supporting them, right? You're contributing money to RECs. You are encouraging additional people to purchase renewable energy, right? You're encouraging additional people to build renewable energy projects, but it matters a lot to build new capacity that is not on the network yet, right? Build new solar generation, say. And so several storage providers are really taking a lead on doing this. Kevin's initial prototype for PiKNiK ran using a whole solar array on the roof and had battery storage overnight to be able to continue to process sector proofs overnight. Descent, here's a picture of Descent Hosting's roof. The Filecoin Foundation really generously gave them this grant to put solar on their roof and set all of this up in a way where the output from these solar panels, which are just being installed now, is going to be available via a public API. And we're then going to be able to see, right, okay, which hours is the storage provider running, using solar on their roof. Whole on Investments is also exploring a bunch of options in this area, including just building an entirely new solar farm in Australia. And so, we're really interested, right, in your ideas as storage providers. And, if you are a developer, if you know developers, how can we support people to build tools that allow you to, build new solar, make renewable energy use transparent, right? So get an API that shows the output from your solar farm, match it to your energy consumption, and make that publicly available so people can do calculations based on this and really raise the bar for public verifiability of sustainability claims. How can we prove load shifting? So grids have different carbon intensities at different hours of the day. Can we build tools to allow you to prove that you've shifted your load towards hours that are less carbon intensive and show how many emissions you've avoided by doing that? How can we supply granular data concerning power use and use that to underpin these sorts of sustainability claims? So another thing that we've done as Protocol Labs is invested money to build new solar projects in the US. So this is going to be primary financing in order to support distributed solar across the country. This fund is it's $38 million total. We expect it to produce on a year average basis about 3.5 times as much electricity as the Filecoin network consumes in the US right now. So this is another example of where, can we not just buy renewable energy through these energy attribute certificate markets, but can we actually cause new capacity to be produced and really catalyze the renewable energy transition, really speed up the shift toward renewable energy. So a third part of this that we're working pretty hard on is improving verifiability. And so the question here is, okay, you are an enterprise storage provider. You would really like to be able to make these sustainability claims for your clients or for your investors and have people say, okay, we not only see all this data underpinning these sustainability claims, we've read this report, but have some additional level of verifiability that you're not just making this stuff up, right? And so can we take data from a bunch of these different sources and can we store it on Filecoin in a way where the human readable components and also machine readable outputs from this are associated together and verified by some third-party auditor? And so we're working with an auditor to build this pathway, right, for verifying these public sustainability claims. Our thought right now is that the input is going to be the miner IDs that you're using, things like power bills, things like documentation of your setup, maybe an API showing the PDU energy use if you have access to really granular information about your energy use and you want to share that publicly. And then the output will be this third-party auditor, which has a lot of experience auditing supply chains, will say, yes, we actually do believe we've looked at a lot of this data and we believe that these miner IDs are actually using this amount of electricity. Here is their rough location, not the exact address, because you probably don't want people to know that publicly, but here's the city that they're based in, or here's the county they're based in, the zip code. Here's the embodied emissions in their hardware. And have this third party say, okay, we've actually looked through all of this stuff and we believe these representations that the storage provider has made. And so if you're interested, if you're scoping out a storage provider operation and you want to participate in this, please get in touch as we're building out this program. This is also an example, right, of where we are using Filecoin itself to upgrade sustainability claims, right? We really want all of this data to be associated in a way where you can make sort of typical investor statements, statements aimed at investors to show them your sustainability claims. and also machine readable statements so that people can build on top of this, right? And say a client really wants to store with a storage provider that has not just purchased renewable energy, but makes it clear how much electricity they're using every hour, and where on a power grid they are, so that they can really do a really good job tracking the embodied emissions, right? What can we do to build tools to allow you to make those claims and allow clients to differentiate between different levels of sustainability claim? So, we're really excited to talk with you. Please get in touch. You can email green@filecoin.org. If you're on Filecoin Slack, there's a Phil Green channel where a lot of announcements get made. You can sign up for updates at tinyurl.com/filecoin-green-updates. We're also going to be hosting a sustainable blockchain summit at South by Southwest in just under 2 weeks. So on the 13th of March, which is a Sunday. And I'm happy to take any questions. There's one in the chat already from Arcady. How does this being renewable energy markets compare with something like Toucan? So, there's when people are making these sorts of sustainability claims and they want to participate in public markets for environmental products, there are two different types of market they can participate in, right? One is purchasing renewable energy. The other is carbon offsets, right? And carbon offsets themselves are differentiated into all these different, types. Toucan is on the carbon offset side, which is, it's interesting and it's very much something we are, aiming to get involved in and have talked to a lot of people about and have some ideas on. There's a lot of different things that offsets mean to different people, right? Really high quality offsets are things like carbon removals. You're taking carbon out of the air and proving that. Some of the lower quality offsets, theoretically, they've avoided a ton of carbon, but there's a lot of question marks as to how you actually validate that, right? And there's this huge spectrum in between of offsets of different quality. With renewable energy markets, so like EACs, it is always true that when you have purchased a renewable energy certificate, you have purchased 1 megawatt hour of electricity that is being supplied to the local grid, right? So that is how this compares, directly answering your question, Arcady, that's how this compares, right? Is one is a market for renewable electricity and the other is a market for carbon. And what I just showed was renewable electricity markets. Clara is also saying we have a storage provider meetup at South by Southwest. Yes, the Filecoin Foundation is doing a ton to support this community. And please check out all of their programming too. Thanks so much.
Awesome. Thank you, Alan. All right. So last but not least, want to give the team and our viewers the link to all the content. Give me 1 second. We've talked 4 hours for 4 hours and actually almost 15 minutes on the virtual bootcamp. So thanks everyone for listening in. And here you can find the final list of all the collateral assets that have been delivered and that are accessible right now on YouTube for you to watch. You'll see a ton, more than 20 hours of content regarding building service providers. What are we solving and why Filecoin? The economics, Filecoin leasing by our lenders, as we've invited some of our lenders to participate as well in the program. The vision of legal in the future, legal and contracts, Filecoin implementations, community engagement and business development, architectural design, Lotus components, etc. So look at, go to m.phil.org, ESPA bootcamp content, and as you can see here, there's more, and you'll find the YouTube and the slides. You'll find the different categories, and if you can't find the link right away, we're just looking for where it is. Just go to YouTube and just search for Filecoin ESPA bootcamp, and you'll find all the modules there. Very nicely listed out. So these are a ton of hours. Thanks everyone for joining us today. As I mentioned, more information come out down the road. This is all for you. Let us know if there's anything that you're missing that you think we should focus on. We are available on our Slack channels as always, and we appreciate everyone chiming in. And thank you very much again for being a ecosystem member. And that was it for today. So I want to thank all the presenters and everyone who participated and worked so hard on pulling this all together. Again, a testament to how strong the community is, as you've seen today. A lot of community members standing up and presenting, and PiKNiK, the ESPA team, for creating all this amazing content that has taken a lot of months of effort in the hope that we can help the ecosystem grow and grow the storage provider ecosystem in particular. So thank you very much. This is it. We're signing out, and we'll see you at the next event.